No, roba mia. Il tuo computer dov'è? Ok, proviamo il volo. Che ci fai qua? Allora. Allora, ancora non sono 30 minuti. Questo
Sì,
significa che dovresti fare 25 minuti di presentazione e 5 minuti di question and answer. Se
benissimo.
hai bisogno di prenderti questi 5 minuti, me lo dici.
Non credo, ma ok.
Ok?
Ma devo dire adesso giusto immagino. No, no, guarda, va benissimo 20. Problema, non c'è adattatore, io non c'è. Good. This. Possiamo chiudere la porta?
Okay, so we can start. He's Navid Nobani, and he is presenting his talk, Private Generative Models, Balancing Privacy and Utility in AI. So enjoy the talk.
Thank you. Okay, so before I start, I just want to tell you two things to balance your expectations from this talk. We cannot, for reasons of time, of course, go into details of. We see many complex things. I say complex because they are not simple. Okay, so we are not going to details of each and everything that we see here. I try to give explanations for some of them, but not for all of them. So this is the first thing. The second thing is that the slides that you're going to see are really ugly. Okay, so do not expect anything fancy or having. They're really bad. Okay, so sorry for that. So let's start. Really fast, who am I? I'm currently assistant professor in the University di Bicocca, data science and artificial intelligence. My research area is in explainable AI and natural language processing, and I'm really bad in chess. So if you want to try, I'm here. So let's go and start with this argument because, I mean, I think from the title you already saw there are many pieces that each of them has a word inside, right? Generative models, privacy, utility, balancing these things. Okay, so what we do is to make sure that again, in a really high level, okay, but we agree what does it mean? What is a generative model? Anyone can tell me what is a generative model? I like this kind of questions. So, okay, if we have generative models, which we have, okay, and I'm super sure that all of you use them on a daily basis, right? Okay, so if there are generative models, should be some non-generative models. Can you tell me what are these non-generative models? Traditional machine learning models. Good. Can you tell me the difference? Okay. But what makes them traditional? Why they are not generative? Because they are not good enough? Because they are not.
Because they have a constrained prediction space, more constrained prediction space.
Okay. Yes, that's a nice way to look at it. Good. Anyone else? I know you're not here to have a lecture. I know that. Okay, but again, it's important that we make sure that we are on the same page. Okay, so generative models. Let's see. We have generative models. We have discriminative models, and really generally speaking, because I know that's not correct, but what is the difference? It's not so easy. It's not, the definition is not that accurate. So what I wanted to say, tell you here, that discriminative models, okay, as our friend mentioned, traditional models, they try to make boundaries, to decide, to predict, to label. Take a data set and say, okay, giving this data set, the output is that. They are conditional, okay? So this is traditional machine learning is about. Again, I'm Don't hate me if I'm not using the terms in the exactly, let's say, precise semantic of it, okay? But, so, discriminative models try to decide, try to make boundaries. Generative models, they don't care about this. There's not like, give me an X and I will give you Y, okay? It's, give me X, give me Y, and I try to understand the joint probability. What is the probability of having a Y if we start from this X? And again, it's not that easy. Let's say the distinction is not always like this. We have some, let's say, kinds of generative models that actually are conditional, like autoregressive, ChatGPT. It goes forward based on the previous word, okay? So it's kind of conditional. We have Markov models that they are generative, and they are generative, but they also use conditional probabilities. And it's not super, let's say, related to this topic, but can anyone tell me when generative models were born? Is it 2 years, 10 years, 100 years? I can't see who's saying it. Okay, sorry, now I see you. Okay, 10, 15. That.
Even more, but let's say the transformer that are the biggest
okay.
things in the generative models.
Okay.
2015, if I remember correct. Maybe they got invented a little early, but I don't think they have 30 years of history.
Okay. Yes, I'm sorry, but they are actually really old. And that's the thing that I normally use this to, let's say, make people hate me. I try to say, okay, when was born? It's November 22. No, that was ChatGPT, okay? And the generative, the topic of generative models, as our friend is mentioning here, like Markov chain, hidden Markov chain models, they're actually really old, really old. They are classic models. Naive Bayes model, that can be generative. So anything that can generate input based on what it saw before can be generative. So they are not new at all. Pardon me. I know that you don't like to hear it, okay? They are not new. The only reason that we have all this hype now is because layperson can talk with it, and that's it. It's not because like it's the biggest revolution of the world. But we are not here to criticize the generative models. They are nice. I use them. You use them. Let's go for it like this. Okay, so generative AI, generative models, discriminative models. So again, generally speaking, the difference is between their scope. Good. How generative models though create? How they generate, okay? Because we are saying that the name is generative model. And this generation thing, where does it come from? I repeat, make sure that I repeat it in each and every slide, okay? That I'm generalizing a bit too much, but we have the time that we have. So generally speaking, we can say that somehow we have these 5 types of methods to generate data, generate something that we see that it's not always data in that sense. So, any of you is familiar with GANs or autoregressive models, Weil, okay, diffusion models, energy-based models. Okay, so each of these category family of methods, so when we say adversarial methods, it's not like there's one algorithm that does it in that way. There's a big family, especially in that nice guys, adversarial methods. It's a really, really big family. And whatever model you choose from that family, it has many children, okay? They're a big family, a nice family. Okay, so I don't go into details of how they do it, okay? But each of them has its own way. One of them tries to, let's say, generate data, adding noise. Starting from adding noise is something else that we get to that. like diffusion models, start from noise and say, okay, what should I do? How should I change it to make it look like one of my input data? Then we have variational methods that start from space. Let's input a space, take the data in another space, and then try to reconstruct it to create some outputs. Okay, and like this. Okay, so I try to go a bit fast on this, let's say, slide. If we have time, if you want, I can come back and explain a bit more. But we are not here today to understand how exactly generative models work. I think you already know that. Okay, so it's just one was like a reminder. So let's do a recap. How we are using generative models, except creating Ghibli style and asking ChatGPT how many R's are in strawberries. How exactly you're using it in your company, in your research, in your work? I don't know. If not like these things. I know it's a really not so nice question, okay? I'm not judging, but please. Generating code. Okay, that's more fair and that's more decent. Good. Anything else?
Getting wrong hallucinated answers.
Getting, sorry?
Getting wrong and hallucinated answers.
Good. Yeah, that's a side effect. You have it. Anyone else? How you use generative models?
We have a bunch of images for the banners.
Okay.
And we need AI to give us the categorization. For example, like, do we have text here? Do we have
Okay.
call to action button? Do we have this and that? So we give them like a number of categories for him to check all of the images and give us.
Or her. Him or her.
Oh yeah.
I'm kidding. No, that's my glitch, and every time I talk about this, and I say, and he does this, and she does this, we don't know. I'm kidding. Okay, good. Actually, I was expecting somehow not, but I wasn't expecting. All of your examples are actually good examples, because unfortunately, I see a much hype about these kind of outputs and say, you created a woman that had 3 fingers. Wow, we are dying. Who cares? Who cares? Okay, really. But what almost all these examples had in common was that you are using it to generate content. Okay, in your case, you are not generating content. You are actually using it for a downstream task, which is good. Okay, but again, generally speaking, we can. Oh no, he's preparing his timing cards to show me. We can somehow put different applications of generative AI in 3 big families, really big, okay? So first one is content generation. We are all familiar with this, right? I use it every day, like I'm not answering my emails since I don't know how many months. Okay, so generate content. It's fun, it's nice, it's kind of work. It somehow work. But then we have 2 other categories that I think they are somehow going to the corner, pushing to the corner, being pushed to the corner. You find the correct way to say it. So the second one, which is actually one of my secondary research areas, is generating synthetic data. So you have your input, then you want to generate data which looks like the input, but it's not. It's not equal, let's say. Okay, so synthesizing data. The third category, which in my opinion is one of the most, let's say, complex categories in these 3, okay, is regenerate a behavior. So user behavior. So you can generate a model that, for example, in A/B test, you can say, okay, I have this and that, and instead of using it on, let's say, real people, you use your generated person to answer that. I prefer this because this and that. Okay, but we are not going to, how much time we have? Okay, 15 minutes. So the reason we put these categories here is to arrive to our privacy thing. So no, there's no air quote for that. Privacy, we need it. It's nice. Privacy. And where we need privacy, which of these three, in your opinion? All of them. Yeah. All of them. In some of them, a bit more. Honestly, I mean, if someone tells me that the cat looks like me because I'm angry about it, okay, you are not going to die, most probably, hopefully. But there can be really big issues of privacy in, for example, the content generation, yes, but in the synthetic data sets and also in behaviors. So we focus on the second one, creating synthetic data. So we have a data set, okay. Any example, can you think of any example of when we can use synthetic data? Well, okay, but why can't you use your actual data?
Because I need more.
Okay, good, fair enough. Anyone else? Synthetic data?
Personal data such as healthcare.
Nice, okay. Marketing analysis. But my question is, which both of you are correct. My question is, why can't we use our actual data? We close them in a box, no one can see them. What is the problem of that?
Most of the time anyway you have to anonymize it.
It's always you, okay, sorry.
Most of the time anyway you have to anonymize it because maybe you don't deal with that kind of data without the arrangement of the users.
Okay. And you think...
At the end you do it, but you're asking for that.
Yeah. Okay, so you think that creating synthetic data can resolve that, right? Can help with that. Good. Let's see here. Who cares about privacy? There are some examples, some of them unfortunately are real, that when generative models unwantedly, let's say to be nice, leaked some information, some data, okay? For example, especially the family of GAN, okay, that used health data to generate some, let's say, synthetic behavior of some patients, and in the midway they just gave out also information of people, okay, real information. Or emails, phone numbers, API keys. That's actually was a routine thing like 1 year ago to say, then there is a thing that API key was leaked because of this and that. And yeah, and maybe one of the most severe cases is that when we when we are working with real demographic data. So imagine the data that EStat worked with, the National Statistic Institution. I never said it in English. They, in theory, not in theory, they have information of each of us in this room, and they have it in a safe place, and that's a really nice thing, okay? And for exactly privacy reasons, they don't just give you in any case this information, even if you want for research. They say there is a private data, we cannot just, let's say, give this data for whatever reason that you think that you can use and to create models, to predict. The data are private. Privacy, you can't have them. That's it. End of the day. And actually, there are teams, as far as I know, in STAT that work on this thing, and the specific teams that work on data privacy, synthetic data, private synthetic data, okay? But again, that would be a real disaster. Imagine that someone can have that data, okay? Okay, 10 minutes. And what we can do with that data, okay? So now I go faster. So I think until here, I actually didn't say that much, because I think you already know these things. We have generative models. We have privacy. We like privacy. We want to have privacy. Good. What are the ways to have the privacy? So to preserve privacy, what can we do? Don't read it. Tell me if you want, please. What do you think? How you think we can add privacy to our data? So our friend mentioned anonymization. That's one way, right? So you have a data set. Imagine our data, okay? There is codice fiscale, the fiscal code. There is salary, age, gender, whatever. One way is to remove the codice fiscale, right? Another way is to somehow change it. So this is the, let's say, one of the easiest when we want to do it. When we want to assess that actually does it work, it gets a bit tricky because they are easy to do, but normally the performance is not that good. Anyone knows the New York taxi data of 2014? That one thing, so you know it. It's actually, I just put 30 seconds. So what they did, a guy, based on some laws that is in the United States that you can ask for public data, asked for this data of all drivers in New York City with starting and ending locations, okay, and the fare, how much they asked for it for the customer. So all this detailed data, and of course, they didn't give you the ID, the real ID of the driver, because there was another database that says, okay, ID number 1 is this, ID number 2. So they changed it. I think they had used the hash function or something like that to change it, and they published it. So the data is anonymized. You see a line, and there is no way for you to say, who is that guy? Unfortunately, it wasn't the case. Unfortunately, I don't know the name, but a guy understood how they hashed these IDs because there was an error, and because when the ID was missing, they were putting 0, okay? And the guy did it like a sum and saw that that specific ID is doing really well. Is let's say, have a high income. So I said, okay, it should be 0, that code. So find the function, find all the IDs, match them together, and found all that private information of that people. So anonymization is a nice thing to do. It's an easy thing to do somehow. It's not so, let's say, performance all the time. Another way is adding noise. Oh, that fast. 5 minutes. Another way is to add noise. So we take the real data, we add a bit of noise, we change it a bit. In theory, we are still close to input data, but not exactly. We are not exactly the same thing, right? Okay. Really fast, really broad categories, how we can achieve, let's say, privacy. The first one, and the most common one, is differential privacy. Anyone does that? You do. Sorry for that. I mean, it's you have some headaches. I think it's when you read about it the first time, it's easy. You add some noises, and we are all happy. And it's a nightmare if you actually want to guarantee the privacy from a mathematical point of view. It's not like add something and you're good. So differential privacy, in theory, guarantees the privacy and guarantees that no one single record can alter the output. Another way is PATE group, private aggregation of teacher ensembles, where student models don't see the data. There are some teacher models that look at the data, learn from it, and then teach another model, adding some noise. So the end, let's say, model won't see the data, the real data. Federated learning, when you don't share data, you share a model performance through different nodes, 2 minutes, and synthetic data. You see? Is there anything that has too much privacy? Yes, no? Yeah?
Well, if you add noise to the training data, then you might lose some performance.
Thank you. Yeah, that's the thing. I mean, privacy is good. We like it. We want it. We're happy about it. We are happy about it. But we can unfortunately have too much privacy, okay? And that happens, when that happens, we are lowering our utility performance. Look at this very simple case, iris data set. So I took the data set, I add some noise, and in each, there are 3 levels of noise, okay? So the blue one is the real data set, and the yellow one is the generated one. So you see in the first place, when we have noise standard deviation of 0.1, okay? Let's don't go in the details of what is Westersian distance and SNR. There are two ways to assess privacy and utility. And you see, when we get there, the privacy goes up. So we are super happy about it. No one will ever understand what was the real data. And that's also a problem. Which is the best one? Don't say the middle one. There is no easy answer. It depends what you want to do, what is more important. Again, for eStats, the most important thing is privacy. Privacy, privacy, privacy. They don't want, and which is a really nice thing, I thank them, they don't want to leak any information, any private data. So privacy, all the time. Really fast, really. So how we can measure it? Because it's not like it's subjective things, and you say, oh, okay, here it seems like too much, let's say, it's too wide, so we need to measure it in a numerical way, okay? So there are many different categories and metrics to do that, but in my opinion, 3 main categories are privacy metrics, sanity checks, and statistical metrics. Privacy metrics, okay, they somehow quantify how private is your data set, the synthetic one. And sanity check and statistical metrics try to say, this was your initial data, this is your output data, how much they overlap. So look at the first one. You see here, real data and original data actually kinda completely overlap. The second one, we didn't do a good job. That's the slide. Fast recap. So we know that we have generative models, we have non-generative models. What is the difference? We know that there are 3 different types of generative models, okay? Content generation, synthetic data, and behavior simulation. And all of them can have privacy issues. And we know that improving privacy means decreasing utility, and vice versa. So what is the correct point? It depends what you want to do. What are your data? Thank you. So that was it.
Thank you very much, Navid.
Thank
we
you.
have time only for 1 question, 2 minutes. If using generated data to anonymize, wouldn't that have the same risk of leaking training data?
So if I create synthetic data, is there any risk that I anyway leak data, leak information? That was the question.
Yes.
Of course there is. Unfortunately there is. I mean, that's why we have all these, let's say, different metrics to understand, okay, so you created synthetic data, so it means that none of these data points, new data points, are too close to the initial data point. So yes, there is unfortunately a risk for that. That's why we need to evaluate the whole, let's say, generation process.
Okay, just the last question. Could you briefly explain the concept of latent space in generative models in 30 seconds? I don't know.
Not even who created that thing. Okay, so I try to be fast. In 30 seconds. Our data almost always has more than 2 spaces, 2 dimensions. When we have 2 dimensions, we can draw it. When we have 3 dimensions, we can imagine it. When we have more than 3, we can't even imagine that, okay? Our data, most of the time, has hundreds, depending on your input data, dimensions. So latent space is when you take that input, okay? So imagine that your input is on 3-dimensional space, okay? You transfer it into another dimension. So you start from some dimension, you transfer to another dimension, another space, okay? So your data points are still there. Now they have or more or less information with respect to the initial point, okay? For example, these VAE models, they try to start from input, take it to the latent space, add a bit of noise, and take it back here. And when you do it, you see that the initial point and the output point, they are not exactly the same thing, which is our point. We want to add a bit of noise. So transfer, retransfer, adding a bit of noise in this cycle.
Okay.
Hopefully it was clear.
Okay. Thank you so much, Navid.
Thank you.
Excellent talk. If you have more questions,
It's
please
my
feel
email.
free to continue the conversation outside, so we can get ready for the next session. Coming up next, Alessandra Bilardi will be presenting the art of data visualization.
Thank you. Thank you. Grazie. Grazie.
Prova.
Ok.
Ok. Prendo questo,
Prova.
lo metto qua.
Abbiamo ancora 3 minuti.
Ok.
Ok, benvenuti. Adesso sto per lasciare la parola ad Alessandra Bilardi che ci presenterà The Art of Data Visualization. Vi ricordo che per la sessione di Question and Answers potete utilizzare l'app Slido. Ok? Un applauso.
Ok, il link, il QR code va alle slide, quindi le ho messe soltanto perché ci sono una serie di link che potrebbero essere utili. Al banchetto della community troverete i gadget di PyData Venice e Corley Cloud, l'azienda per cui lavoro, e direi che possiamo cominciare. Ok. Allora, io sono Alessandra, lavoro con i dati da 20 anni e in Corley, che è un'azienda di consulenza che lavora con AWS, mi occupo di gestire soluzioni in cui il dato è il protagonista. Quindi lavoro il dato a 360 gradi, dalla data ingestion all'analisi e la trasformazione, predizione e generazione, fino alla visualizzazione sia per monitoring che per business. E mi occupo anche della parte di automazione con metodiche di DataOps, DevOps, MLOps e LMOps. Oggi andremo a vedere la visualizzazione dei dati in ciascuno di questi step. Quindi andremo a comprendere l'importanza di conoscere quel dato per sapere come comportarsi in quello step o se possiamo passare al prossimo step. E in più andremo a vedere quali sono le librerie che potrebbero esserci utili o che potrebbero insomma semplificarci la vita e l'importanza di come visualizzare i dati al nostro pubblico, quindi a chi osserva i nostri grafici per trasmettergli in modo intuitivo il nostro messaggio. Su questo stresserò un po' perché l'idea principale è proprio questa. Il nostro osservatore non deve ragionare sul grafico che stiamo presentandogli, ok? E deve essere concentrato invece su quello che gli stiamo dicendo. Quindi, quali sono gli step in cui potremo avere bisogno di visualizzare dei dati? Tutti gli step hanno bisogno di grafici differenti, ok, sicuramente, però tutti gli step hanno necessità di visualizzare qualche cosa. Per esempio, nella data ingestion abbiamo necessità di organizzare il flusso di dati, okay, che ci arriva. Quindi abbiamo bisogno di sapere quali sono, qual è la frequenza con cui arrivano i dati, quanti dati abbiamo, e quindi l'idea principale è comprendere come visualizzare e spiegare al nostro cliente, al nostro responsabile, qual è la soluzione migliore da utilizzare. Chiaramente non siamo noi a deciderla, sarà il cliente o il responsabile, ok? Però dobbiamo metterlo nelle condizioni di capire questa situazione. Quindi comprendere se è meglio un sistema di real time, quindi un streaming, e quindi una situazione in cui prendiamo pochi dati però cioè elaboriamo pochi dati, però abbiamo una macchina che è sempre accesa, quindi c'è un costo abbastanza alto, ok? Oppure se abbiamo un sistema in batch che quando va a eseguire lo script o lavora pochi dati perché lo facciamo in modo frequente, ma quindi abbiamo un costo elevato, oppure abbiamo tanti dati, ma lo facciamo in una frequenza minore. Okay? Quindi avremo un costo che è minore. Ok, le due possibilità che abbiamo per rappresentare queste informazioni, queste tre variabili, quindi il costo, la frequenza e la quantità di dati, può essere o di questo genere, quindi un grafico a bolle in cui abbiamo sugli assi il costo e la frequenza e sulla bolla abbiamo la dimensione della quantità di dati, e l'ultimo punto è più alto perché fondamentalmente abbiamo troppi dati, tali per cui il sistema in batch richiede più risorse. Okay? Oppure possiamo utilizzare una linea. La linea però quello che fa è rappresentarci solo due variabili. Okay? Per rappresentare tre variabili dobbiamo aggiungere un secondo asse y. Okay? Quindi l'idea è comprendere se è meglio fornire, lavorare e spiegare al nostro cliente o al nostro responsabile la situazione con un grafico a bolle oppure con un grafico a linea. Per fare questo fondamentalmente dobbiamo capire un attimo come funzioniamo, cioè che percezione ha l'uomo su la visione di un grafico, ok? Quindi come elabora le informazioni. Poca teoria, non tantissima. Alcuni concetti. Attività precognitiva. L'attività precognitiva è quando noi andiamo a vedere un'immagine, viene processata nella nostra corteccia visuale e prima di arrivare al livello cognitivo, quindi prima di andare nella nostra memoria o nel nostro pensiero, ci sono queste attività precognitive che ci permettono di avere immediatamente, e quindi intuizione, ok? Quello che è, per esempio, la linea dell'orizzonte, oppure sapere che in questa stanza non ci sono 2 persone, ce ne sono molte di più, ok? Sono concetti che noi abbiamo istintivamente, ok? E quindi quello che succede è che queste attività sono svolte in modo velocissimo perché non richiedono il livello cognitivo, ok? C'è una branchia della neuroscienza che proprio studia la percezione dell'uomo davanti a un grafico, sia in termini di velocità che di comprensione. E questi 2 signori, Cleveland e McGill, hanno definito un ranking della graphical perception. Quindi andrò veloce perché effettivamente non abbiamo tempo, se no non vi racconto tutto. E quindi in pole position abbiamo lo scatter plot e le mappe a punti, ok? E a seguire abbiamo una matrice di grafici a punti o tabelle, ok? Quindi più andiamo, saliamo diciamo di livello 1, 2, 3, ok? E più tempo ci mettiamo a elaborare, ok? Ma sempre in termini di attività precognitiva, ok? E queste informazioni, quindi a dare una risposta. E poi ci sono i grafici a barre e gli istogrammi, a seguire le torte. Poi abbiamo i grafici a bolle e a seguire le heatmap e infine le tonalità di colori, che non è il fatto che io evidenzio in blu la linea 7, ok? Che chiaramente se stiamo parlando, vi siete distratti e non è evidenziata, magari uno si perde, ok? Ma è il fatto di utilizzarla come tonalità e utilizzarla nel, per esempio, definire la distribuzione dei dati all'interno di una mappa, ok? Questa è la tonalità di colore. Quindi, tornando alla nostra domanda, qual è più semplice, il bubble chart o il line chart? Beh, allora il bubble chart è livello 5. Invece il line chart è un misto. Allora, intanto la linea è un insieme di punti, ok? Quindi per Cleveland e McGill la linea sta tra la prima posizione, in cui appunto quella è una linea, lo sappiamo già, ok? Senza arrivare a livello cognitivo, e il quarto livello, che è quello per identificare un trend, ok? Quindi il grafico che dobbiamo sfruttare con il nostro cliente o con appunto il nostro responsabile è di questo tipo, delle linee, in modo tale che intuitivamente capiscono qual è il trend e ci seguono nel discorso che stiamo facendo, ok? Questo è il punto chiave. Ok, quindi abbiamo definito qual è la soluzione da utilizzare, o più o meno quella che vorrebbe il cliente, ok? E andiamo a capire quali sono invece i tipi di dati che ci arrivano, ok? Perché potremmo avere un formato tabulare piuttosto che un JSON, ci arrivano tutte le feature oppure no, abbiamo delle feature annadiate, oppure sono immagini, video, audio, quindi insomma può essere di tutto. E la cosa importante è fare analisi esplorativa per ottenere le informazioni che ci possono servire per controlli o trasformazioni prima di salvare il dato. Perché banalmente immagini, video, audio sono abbastanza pesanti e magari hanno una risoluzione bassa e noi non vogliamo salvarli, ok? Quindi dobbiamo saperlo prima, quindi andare ad esplorare. Quali tool ci possono dare un aiuto in questo? E, il link a questo titolo è un notebook in Kaggle che potete utilizzare o su Colab o in locale, non si vede tutto su Kaggle. E, sono andata a guardare una ventina di tool, ok? Quelli che sono open source e mantenuti, ok? Sono questi 4 e che cosa offrono? Offrono la possibilità di avere la correlazione, tipo correlazione di Pearson, e tra le feature e possiamo vederle come una tabella oppure come degli scatterplot, ok? Quindi qualcosa di intuitivo subito, e, oppure effettivamente delle heatmap che io ci metto anni a capirle, non so voi, ma una cosa simpatica è che per esempio YData mette a disposizione un grafico interattivo, ok? E invece Klib, questo lo capisco, è un heatmap a singola feature, ok? E poi per quanto riguarda la distribuzione, sono principalmente, stiamo parlando di istogrammi, quindi con i quali possiamo individuare quello che potrebbe essere un'anomalia o un outlier di qualche tipo, e normalmente la distribuzione è arricchita da un po' di statistica come conte, medie, deviazione standard, skew e cose di questo genere. Per quanto riguarda i missing data, ci sono 2 bei grafici, secondo me, che definiscono quelli che sono la quantità di dati che ci mancano, e quindi un grafico di tipo bar chart, e che magari è per percentuale o per conta e ci definisce appunto quanti dati ci mancano, oppure la heatmap che ci identifica invece com'è com'è distribuita il dato mancante, se magari abbiamo proprio un gap che è proprio visibile sulla heatmap oppure è distribuita nel tempo o in quella dimensione. Ok, che cosa non vi ho parlato di PyGWalker. PyGWalker è un po' diverso dagli altri 3, tutti e 4 con poche linee di codice possiamo ottenere tutto quello che vi ho mostrato, ok? Stiamo parlando di 1 o 2 o 3 righe di codice, ok? E PyGWalker è leggermente diverso perché è un'alternativa open source a Tableau. Quindi per quanto riguarda la parte di distribution, drag and drop, facciamo quello che vogliamo e vediamo. Tra l'altro permette di estrarre i data frame che creiamo per creare le distribuzioni e di utilizzare il nostro notebook. Però per quanto riguarda la correlazione e i missing data, fondamentalmente dobbiamo creare dei campi calcolati, quindi non è proprio comodissimo. Ok, ammettiamo di aver quindi l'idea generale di quello che dobbiamo fare per la data ingestion, implementiamo la data ingestion, quello che ci serve è il monitoring. Per quanto riguarda il monitoring, vi ho portato un esempio il link punta a delle dashboard di Grafana di un'azienda che fa monitoring da 15 anni. Okay? Quindi ha una certa esperienza nel preparare dashboard di monitoraggio. In questo caso sono dashboard di monitoraggio di database, però fondamentalmente quello che ci interessa è come le fanno. Okay? E ve li ho messe in scala di human perception, okay? E quello che possiamo vedere è che ci sono tante informazioni, okay? E questo vuol dire livello cognitivo, ok? Però siamo in un monitoring, abbiamo il nostro caffè in mano e quindi possiamo benissimo pian pianino guardarci queste dashboard. E allora fondamentalmente cose importanti che ci sono sicuramente le barre verticali per quello che potrebbe essere una release, molto importante per quanto riguarda il monitoraggio di una qualsiasi tipologia di soluzioni di sviluppo, e dopodiché ci sono tante informazioni per quanto riguarda gli assi e addirittura delle statistiche per ciascuna item che è visualizzato. Idem per quello che potrebbero essere i grafici a linea. Cosa molto importante è il fatto che tutti questi grafici dobbiamo appunto lavorare con la parte cognitiva. Quindi non abbiamo l'intuito di ah caspita cosa sta succedendo, ok? Subito. Invece con grafici di questo genere in cui sono stati spogliati di tutto, fondamentalmente abbiamo idea subito, la linea ci dice se c'è un problema o no. Cioè se fosse completamente piatta, ah ok, passiamo direttamente al prossimo grafico, direttamente con lo sguardo e non ci pensiamo neanche. Ed è proprio questo il senso, attività precognitiva. Vedo, linea piatta, passo all'altro. Vedo, linea piatta con un picco alla fine, santo, e poi faccio un'azione. Ok? La cosa importante è che è attività precognitiva perché? Perché trasmette soltanto l'informazione che deve fare, ok? Cioè pericolo o statico. Altri grafici molto intuitivi sono gli status map. Qui la parte importante sono i colori, ok? E i numeri li vediamo fra poco. E potrebbero essere istanze come prima, oppure trattarsi di traffico, e quindi dobbiamo immaginarci per esempio il fatto che queste linee potrebbero essere verdi e rosse a seconda di funzionano o non funzionano, ok? Oppure di quantità di errori, ok? In una mappa oppure anche in un processo, in realtà non è detto che sia per forza una mappa del mondo. Ok, gli altri sono più complicati ma non abbiamo il tempo di vederli. Punto importante è il colore. Ora, nel momento in cui abbiamo delle persone, degli osservatori che sono daltonici, questo nella peggiore dei casi lo vede così, ok? Quindi cosa succede? Ecco i numeri. I numeri servono per identificare se è, cioè insomma spiegare a chi non può vedere i colori la situazione. Però a quel punto quell'osservatore sta pensando 18 è meno di 58, ok, allora 18 non mi interessa, gli altri mi interessano. Non ci sta più ascoltando, ok? Quindi è necessario utilizzare dei colori che gli permettano di essere intuitivo e utilizzare solo attività precognitiva anche a una persona tipo un daltonico. Ok, il resto. Punto principale è che se andate a vedere quelle dashboard, principalmente sono scatterplot, line chart e status map. Quindi qualcosa di molto semplice e intuitivo, anche se magari è pieno di informazioni. Ok, abbiamo preparato la nostra data ingestion, quindi passiamo a quella che è la data transformation. Ora, in realtà non cambiano i grafici, ok? Sia per quanto riguarda il monitoring che durante. Una cosa importante da ricordarsi è che fondamentalmente, sì, ho messo anche la prediction, perché prediction è generative, perché fondamentalmente dipende dall'obiettivo. La data transformation fondamentalmente ci porta a quello che è il nostro goal di business, ok? Quindi fondamentalmente potrebbe essere che dobbiamo trasformare magari le immagini e video, dobbiamo trasformarle oppure sintetizzare dei dati, fondamentalmente potrebbe servirci prediction o generative. Ok, qui vi ho messo dei link a delle librerie mantenute che possono essere utili per la parte di data preparation, e questo è un esempio di come durante la trasformazione del dato e quindi la preparazione dello sviluppo una persona può cominciare a creare dei grafici e comprendere con il cliente se è quello che voleva. Okay? Quindi c'è questo tipo di grafico importante che serve per portare il cliente o responsabile che sia, a capire se era quello che voleva, okay? Oltre a tutta la parte di monitoring che è praticamente la stessa. Allarmi e flussi chiaramente saranno diversi, però fondamentalmente i grafici in realtà no. Per quanto riguarda la data visualization, ricordo che questo bisogna stamparselo in testa. Okay? Il ranking the human perception è importantissimo. E un'altra cosa importante è, scusatemi, lo rimetto, e comunque avete le slide volendo, e l'altra parte importante è questa. Penso che siamo tutti d'accordo sul fatto che la griglia è un po' importante, ok? E che se spogliamo il dato dalle informazioni che non servono, invece arriviamo a fornire all'osservatore ciò che vogliamo che veda, ok? Il data inc ratio è fondamentalmente l'inchiostro che viene utilizzato per il dato con il rapporto di tutto l'inchiostro utilizzato per il grafico. E questo rapporto deve essere prossimo all'1. Ok, la tavolozza dei colori che ci interessa per quanto riguarda la parte del daltonismo è Viridis. Se la vostra libreria non ce l'ha, fatevi una domanda sulla libreria. E un'altra cosa molto importante è Color Brewer, che presenta una serie di tavolozze per diciamo, favorire anche tutti i daltonici. Volevo presentarvi effetti speciali, ma non ho tempo, quindi finisco con elencarvi una serie di strumenti, questo è l'ultimo, in cui ho messo a confronto matplotlib con una serie di librerie che fanno qualcos'altro, ok? Non ho messo per esempio Seaborn perché fondamentalmente è un wrapper di matplotlib, ma Bokeh e Plotly interagiscono con il grafico e esistono dei notebook che fanno solo quello, al posto di Jupyter, sono alternative, interagiscono con il grafico. Chiaramente sono nel cloud, quindi ho presentato anche due tool, hanno una parte free, che millantano di essere low code. Okay? Ora, per quanto riguarda diciamo, questo gradiente, quindi matplotlib, ci sono troppo codice da scrivere, in realtà quello che sono andata a vedere è che per i grafici che ho fatto, fondamentalmente nel momento in cui si comincia a fare qualcosa di un po' più complicato, quindi 2 assi Y, in realtà gli altri cominciano ad avere un casino di parametri da mettere, ok? E sopra il link è a un altro Kaggle notebook. Quindi non sono tanto sicura di questo gradiente, ma sono sicura di questo, cioè matplotlib è sicuramente quello che ci permette di personalizzare al massimo i nostri grafici. Ok, grazie a tutti. Questo
grazie.
è il QR code per il feedback. Vi ringrazio se mi date del feedback per questo talk.
Perfetto. Grazie Alessandra. Innanzitutto abbiamo 2 minuti per qualche domanda. Vediamo un po' cosa c'è. Allora, la prima è: come posso approcciare la necessità di visualizzare molte feature? Per esempio, per l'ingerenza di modelli di machine learning è molto utile valutare per ogni colonna delle tabelle di input, anche 200, del modello, se cambia la distribuzione dei valori.
Allora,
è chiara la domanda?
Come?
È chiara la domanda?
Ci provo, perché potrei averla interpretata. Allora, normalmente quello che faccio è utilizzare un grafico per correlazione per definire quali feature sono correlate e poi lavorare fondamentalmente con PCA per ridurre quelle che sono, diciamo, correlate, e a quel punto vado a utilizzare un grafico a linea piuttosto che uno scatterplot a seconda di quello che è la necessità fondamentalmente. Quindi prima bisogna semplificare e poi appunto si può procedere.
Ok, ce n'è un'altra. I grafici interattivi sono molto richiesti, nascondono difficoltà aggiuntive per chi ha disabilità?
Assolutamente sì, perché fondamentalmente hai la possibilità di avere dei punti che si muovono, quindi dipende anche da che disabilità ci sono e fondamentalmente lì sì è necessario utilizzare il texture per definire questo fa questo, questo fa quell'altro, quindi fare in maniera tale che o texture o tooltip siano utili per comprendere che cosa fa ogni, diciamo, pulsante o leva.
Ok, non abbiamo altro tempo per altre domande, quindi se volete fare altre domande potete farle al di fuori qui fuori, potete anche stare con Alessandra. Il prossimo talk sarà di Tanu Batra, Demystifying Design Patterns, a Practical Guide for Developers.
Dopo se un attimo vorrei scambiare.
Try that.
Can you hear me now? Yes. Good. Yeah.
Questo te lo puoi mettere in tasca,
This
in
one?
your pocket. Okay, we can start. She's Tanu Batra. She's presenting us Demystifying Design Patterns, a practical guide for developers. Excuse me, you can use Slido to do questions. Thank you.
Okay, first of all, thank you everyone for joining today. Really appreciate it, you guys taking up the time, and I'm so glad like people are super interested in this topic, given that the main highlight had been AI ML. So mostly this topic is in the track of engineering, design, software systems. So I'm pretty sure if you learn like one nugget, it will make my presentation successful. So I'm Tanu, I work for Bloomberg. This conversation that we're going to talk about is mostly about design patterns. So let's get into it. So what do you think about when you think of, what comes in your mind when you think of a spaghetti code? Like just spit out whatever you think of spaghetti code looks like. Anything in the room? Messy code? Yes. Legacy, yes. Everything comes under spaghetti code, I agree. So spaghetti code, like a piece of code which has a lot of functions. There are like so many methods which you just can't even figure out what does that class do. Does it ever happen with anyone? Okay. Good, I like to read the room. So maybe like so many functions, like you don't even know why that class is named like that. Like xyz.com, or this is the name of a company. But I don't know what that page is doing, giving so many features, functionalities. But what causes spaghetti code? lack of planning, tight deadlines, or maybe adding features without refactoring. The problem is, even if you put everything together, there's a high chance that things may not work properly on time, because you can't plan everything ahead of time, right? Giving a short intro, I'm Danu. I work for Bloomberg at the New York office. And throughout my career, I have used design patterns and system designing thoroughly, very rigorously, which has helped me become a better programmer. So I hope this whole conversation will help you avoid poorly structured code. So the agenda for today is, we'll first go through the basic pillars, in which I'll cover what is UML diagram, solid principles, which I sometimes expect people to know, but it's okay, we'll do a refresher. And then eventually we'll lean into categories of the patterns, starting from creational, structure, and behavioral patterns. We need to understand the UMLs and solid principles before we get into the integrity and intricacies of design patterns, like what they are, how they look like. So, starting with the UML diagrams. So UML diagram are basically like a narrative of how you want to show or present a software, like how it looks like. For example, UML diagram, when you have a visual presentation, very basic example, inheritance. You're inheriting class, having an abstraction. It's a visual communication tool for a software system. So how inheritance looks like, we discussed about it. So let's say this is the class, and you're inheriting, and you have two types of payment, cash and card, and there is an abstraction of payment. So you're just deriving and sharing the behavior of the parent class. It's a relationship. All these things really important before you move into the next topic. It's a relationship and a dotted line, and it's cash is a payment, as I mentioned, card is payment. Very basic. Moving on to the next very important concept, which is aggregation. Is like how objects reference to the other object. We are not creating an object, we're just referencing. The objects already exist. So for example, playlist has a list of songs, right? Song, multiple songs, playlist, composes. So the way you express is with the diamond, it has a relationship. Inheritance is a relationship, it has a relationship. So diamond with a solid line, and a playlist has songs, as I mentioned. Moving on to our next basic pillar, solid principles. It's a set of guidelines for software development, and it will help you move away from a messy, unstructured code. These are not strict rules, but like practical guidelines, which are recommended to use, and I'll explain you what this whole thing is about. Solid, and I'm done for the presentation. Bye. I'm kidding. So starting with the first one, single responsibility principle. This principle explains that a class should do one and only one thing. One thing, single responsibility. For example, let's take an example. I am a huge fan of examples because I don't understand concepts on a higher level. So every concept that I'm talking about will have an example. So let's say this is an order class, which is doing, what it does is it's processing an order and it's sending a confirmation, right? Very, very basic structure, class doing, processing an order and sending confirmation. But there is something missing. This is not the right way to make a class. What the class is doing two things. It's not only processing the order, it's also sending a confirmation. That means the class is doing more than one job, which breaches our single responsibility principle. So how do we fix it? You break the class, order class, into notification manager, which just takes care of sending the notification, and it breaks into another class, order, which just processes the order. So two things, separate class, single responsibility, no mess. Moving on to the next principle, which is open-close principle. Software entities, basically class should be open for an extension, but closed for modification. What do I mean by that? Another example, so let's say we had a notification manager, which is sending an email confirmation. Right? And let's say, product, like who is a big fan of a product coming up with a new requirement and asking you to fix something or add another feature? For example, now they ask you to add SMS notification. Okay, it should be easy for product to say like, oh, just add one more. You already do email notification, why not just add another one? And what we typically do is just pick the class, add another method, send an SMS notification in the same class, which is wrong. You actually modified an existing class. This is definitely not a way to create a robust code. The way to fix this is, first of all, abstract. Abstract what the feature is. That means create an abstract class which is only going to take care of notify. And then you create the concrete classes, making email notification and SMS notification. So this is how you take care of the open-close principle. You didn't modify an existing class. You didn't add another method or class or function in the function in a class. Whereas you just created another class and then you just extended from the parent class, creating another class without modifying an existing class. For the sake of time and for the sake of this presentation, I'm going to skip to solid principles, and I'm going to move to the last one, dependency inversion. Super important. So entities must depend upon the abstraction and not on the concretion. Let's see. So here is a user repository which is directly calling a DB connection. Very basic example, database connection. You want to call the database, get the user information, or get something. So there is, if you observe, there is a tight coupling between these two classes. They are like tight dependency. So something changes in DB connection, it will ripple back to user repository. You will be forced to change the user repository, which is a bad way of writing code. So the way you fix this is, using a dependency inversion, is you abstract and don't make them directly depend on each other. That means a higher level class should not depend upon a lower level class directly. They should depend via an abstraction. So dependency inversion states that it could be vice versa, because the abstraction will be wrapping around as per the client. Client says, give me user data. Next time database changes its signature or changes something in the method, client doesn't care about it. The abstraction will take care of it because this method signature stays constant. So don't make them dependent directly. Have an abstraction between them. So now, like, just to give you an example why we're learning these examples, why it matters, is if you do this way, you know that testing becomes a huge part of the problem when you do not know how to add a mock. If you have concrete dependency, something goes wrong. This helps you exactly. This is the way you not only can inject mocks in a proper way, but it's like the ripple effect from the repository on the lower level classes would less likely impact your client. So this is what basic pillars. I'll conclude the basic pillars. Moving on to the main topic, which is design patterns. Who has remotely heard or worked on like any experience in design patterns? Like anyone in the room? Okay, nice. So what do you think? I know this is a definition, but any thoughts? What are design patterns? Anyone? Structuring. What comes to your mind when you think of design pattern? Reusable models, yeah? Anything? Yeah, like reusing something, some problem you're having, you want to have a recurring solution. Totally. So these are like pre-packed solutions, basically what you talked about and what you said, for typical software design problems. But how do you define a problem? That's also a very, very important thing. Like, how do I define a problem before I get the solution? So you need to understand what the problem is. What am I trying to solve before I could even propose a solution? So for that, you first need to understand the categories of pattern. So like which category of design pattern you're trying to solve. There are basically 3 categories of design patterns, which is creational, structural, and behavioral. Starting with the creational pattern, It takes care of the object creation mechanism, like how objects are created. It hides how instances are like the concrete class, the way they are created, client need not care about it. For example, there is a car and you have concrete implementation of that one car. Moving on to the next one, giving you a brief, structural, making two different classes, two different structures compatible with each other. Not creating an object, making them compatible with each other. So, for example, I don't speak German, so in order for me, or Italian, for me to communicate with anyone, I need a translator in between. Something like an adapter. That's how I make I make things compatible. Moving on to the last one, the behavioral pattern. This is very, very interesting category, behavioral pattern, because without even we realizing, like there's like a lot of things which come under this category. So let's say if I want to travel from Bologna to Rome, and I just hand it over to a travel agency and I ask them, just make an itinerary. I know it's not too far, but for me as a new person, can you do something for me? They say, yeah, tell me your budget and tell me what's your timelines. Based upon that, I'll do something for you. So you're like, okay, you can go by car, you can go by flight, or if you don't have budget, just go walk. So do you realize like what's the difference? This thing is using an existing system. The travel agency is not generating any mode of commute for me, right? It's just using it. So that's like behavior. It's like composing stuff. So what's the difference between these three categories? Creation, we're creating objects. That's what we are doing. Structure, like creation deals with the creation mechanism. Structure is making things compatible with each other. And behavior is like collaborating and distributing responsibility. Okay, let's use this, and not creating anything new. So I'm gonna pick one category and go through one example in each category to explain you what the underlying behavior that we discussed looks like. Starting with the factory pattern in the creational category. So factory pattern, let's take one example, starting with an example. So a client is creating a card object if he wants to make a payment, and it's creating a cash object, right? Very basic example. And now again, our product comes, saying that, okay, now we have to handle another kind of payment, which is crypto. Typically what we do is take this class and add another if-else condition. Very easy. But do you realize we modified an existing class, right? So how do I fix it? Let's keep our client aside for a moment and keep our concrete classes separate. We know dependency inversion that this shouldn't directly call the concrete class. So let's abstract it first. We abstract the concrete lower level classes by creating a payment class, make them inherit, like what we discussed in dependency inversion. And the client, which was directly creating, which was taking the responsibility of creating these objects, will now use a factory. It will delegate it to the factory. Factory will use the abstraction and will create an object, and client will eventually use the factory and will tell, give me an object of crypto, give me an object of something else. So how does it look like in a code? When you create an object, client, this is how it was looking like. But with factory pattern, you just remove the logic from client, put it in a factory, and just call the factory, tell it what type of object you want. This is how you just, the nasty if-else condition, that will be taken care of by the factory. Client need not care about it. So this is what factory pattern is actually about. It's like creating an object. If you understand the basic category, you will know why are we having this pattern at the first place. So creation pattern, object instantiation, and abstracting the creation process away from the client, right? Now moving on to the next pattern, which is the structural pattern. I'll talk about an example in this category. Again, making things compatible, if you remember, the adapter pattern. So let's say this is one of the examples in which client is trying to create call payment processor to execute a payment, not create, just call and execute. That's it. Happy use case, XML, and let's say something changes in the downstream service, and they say now I want data in JSON format. Very common use case, happens a lot of times. So this breaks, the client will have to change, will have to do some post-processing, do something in between. So basically, you will end up modifying the client, which will be breaching your open close principle. Like you're modifying a class, you should technically extend it. So let's fix this. Let's keep our client aside. Let's keep our payment processor aside. And first of all, let's take care of the abstraction part, dependency. Let's not make them tightly coupled. So let's abstract it. But just abstraction doesn't help, because I have to do the conversion from XML to JSON. So something should be doing the processing, the parsing part. That means I need an adapter in between. Adapter will will take the behavior of the abstract class, which is payment service. And then the adapter will do the parsing in between that was previously supposed to be done by client. And then it will call the downstream service with JSON format. And eventually client will use this abstraction with the adapter linking to the downstream service. So this was like structural compatibility. This is what we did. So how does it look like without adapter pattern? So you are making a direct call to the payment processor. Now, with the adapter pattern, the client needs to call the adapter. Adapter will take care of the formatting and all the nasty business in between, and then finally call the processor. So client just needs to call the adapter. This way, what we actually did is help the client first of all, not change whenever something changes in the downstream service, and also if there was a tight coupling, so there's like testing issues, and if you have them abstracted, this will help you remove the rigidity in the code. So overall, object composition and organization of the classes and the objects. Last pattern, behavioral pattern. So this category basically elaborates how objects collaborate with each other. Think of it as a symphony. The orchestrator is just telling when to play, what to play. The musicians know what to do. So just behave like orchestrating stuff. Not creating, not making anything compatible. Like when to use what, organizing. So I'll take a strategy pattern. This is a very, very common pattern, especially in Python. It's all inbuilt. But what I'm trying to explain you is not how to write a design pattern. I'm explaining you why is it even at the first place, like what lies underneath the basic core principle. So again, taking the example, like client is trying to call, not create, it's calling the card handler to process the payment, cash handler to process the payment. Again, product comes. We need to support another one. You end up modifying your existing class, crypto, which is again breaching, you modify an existing class. Open close principle. So let's fix this. Keeping our client aside, keeping our concrete handlers aside. These are basically strategies. You can call them as payment strategies, card strategy, crypto strategy, and then abstracted dependency inversion. Abstracted. Now this looks better, like they're not directly dependent on each other. And the logic in which the if-else condition was coming to the client will now be taken care by a checkout service in between. So checkout service will take care of the, again, if-else nasty conditions, which was done in the client. And if you remember in the factory pattern, I'll come to the factory pattern, okay. So checkout service has the objects. It's not creating, it's just using it, existing objects. So if you remember when I started, there was is a relationship, has a relationship. When you aggregate, has a relationship. When you share the behavior, it's is a relationship, inheritance. And the client is eventually just calling, like, okay, process the crypto handler, process the payment cash handler. And that's the right way to do it. So if you observe this checkout service, this whole design looks similar. I on purpose took this example because it looks like factory design pattern, which was creating an object. We are not creating an object. The in-between service is just taking care of, based upon a condition, whom to call, not create. So that's like a fundamental behavior difference, what creation pattern does, what behavior pattern does. So this architecture will help you next time when you have, based upon the client request, we want to dynamically process a payment. So next time the client will just tell you, okay, this is the kind of payment method I have, just process it. And without changing the client. Next time you have another class, another type of payment, client won't be impacted by it. It just needs to tell, I want XYZ type of payment, take it. Processing part will be taken care by the checkout service, and you just need to create another class, that's it. How does it look like in the code? So you just create a checkout service and tell the checkout service what you want to process and tell it what type of payment you want to process it through. Client will just tell, okay, like previously it was like card payment, let's reuse the checkout service and inject. Tell it, okay, now I want to process a card payment, crypto payment. And then eventually the checkout service will take the type of strategy and just call process the payment. This way you abstract it, and now we make client away from the concrete dependency between two classes. Last slide. So what we talked about in behavioral pattern is like how objects responsibility like distribute, orchestrating different types of objects together and making them like not compatible, but making them orchestrate with each other. So to add furthermore on this, there are like multiple different types of patterns in each category. So next time if you see any design pattern, ask this very fundamental question, what exactly is this thing doing? Because sometimes we just end up getting bogged by the jargon and we use it without realizing what exactly is happening underneath. So creational category, structure category, behavioral category. So just to summarize what I talked about, because I'm just going short on time. We started with the UML diagram, how things look like. Then we started with solid principles. We understood what the fundamental core principles are in the solid principles. Single responsibility, let the class just do one thing. Open, close, don't modify a class. You can extend it. Behavioral, help change the behavior on runtime. Inject a dependency, behavior, and orchestrating stuff. So, and then coming on to our design pattern, the core thing, creation pattern, how you actually create objects, structural, making compatibility, and behavior, like orchestrating the objects to work with each other, in the sequence or parallelly, again, depends upon the logic. So, yeah, overall, like this is what I wanted to discuss. If you have any questions, feel free to ask, and thanks for being so patient and like listening to me. Yeah.
Okay, thank you so much. It was very inspiring. There are some questions. In your experience, have you came across any design patterns that are widely used in other languages, but when applied in Python, only add complexity without bringing actual benefits?
Yeah, totally. There are like many, but for example, like strategy pattern is something which is inbuilt. You just need to add an annotation, and that's all. I feel like adapter pattern is something which I use often, because sometimes you just have codependency, concrete dependency, and you just want to make those two things compatible with each other. So I use adapter pattern quite often. Factory pattern is also pretty prevalent, because somehow even if it is integrated, you have to tell that, okay, give me an object, and this happens all the time. When you have to create a concrete object of something, you have to create a factory. You just tell it, take care of all the types of objects that might possibly come across, and just like take away the client from the nasty if-else logic. So I suppose, yeah, that should be my take on it. Yeah.
Okay, another one. I want to learn more. Can you recommend a book?
So I would say don't, okay, not don't, but Gang of Four is one book I definitely read, but it's like too much, it's just too much. I don't want you to lose motivation in the name of learning, because sometimes when you end up learning too much, you like forget about what am I even doing. You start losing your interest. I would say there are like couple of YouTube channels. There's a guy who's doing PhD, I forgot his name, in Switzerland. He creates very intuitive videos, and there is this website, Design Pattern Guru, something like that. That website is very is very relevant. It's not intuitive to understand like what is design, because my talk was not about teaching you design pattern. Like I was like, why are you even using it? Do you even understand what you are doing? So I would say, if you want to get into the super duper details, go through the book Gang of Four. YouTube videos help a lot, and what was the name? Excuse me. Refactoring Code Guru something. Yeah, that website is super helpful. So yeah.
Okay. Isn't bringing set of rules killing the joy of coding?
Again, I would say, can you define what is joy? Because everyone has a different definition. Yeah, product has joy in this. When they come up with a new requirement and tell you add something else. Developers don't enjoy. I don't enjoy when a new requirement comes and I have to change like so many classes altogether. But yeah, I know initially it's a lot of work. Initially you have to put up some effort and see the vision, what you want to do. But I would say that I'm not asking you to like follow all these things. It's good to have, but sometimes the deadlines don't allow us to walk us like implement everything in the right way. So I would say depends how you want to do it. It's like it's your call. So yeah.
Okay, just another one. Do you have some examples of real use cases scenarios when one design pattern is generated better than other one?
Oh, okay.
There were some examples.
There are many. So if you see a builder pattern in structural and decorator pattern in again structural. So if you remember, what structural pattern does is it's making things compatible, not creating, not orchestrating, it's just making things compatible. So if you read if you go through the implementation of these patterns, they look similar. Like adapter patterns, again, like creating another wall in between and do the processing in between. Bridge pattern looks similar, but I feel it's going to add more. I mean, it depends, you know. I just can't say this is better, this is not. But I would say in between, sometimes there are more classes and more, like you may have to introduce some more classes in between. But the underlying behavior is the same. You're just making things compatible with each other, right? But again, if it is an adapter, it's sticking with just two types of objects. If you see just German, just English, you can't put Italian here. So you have to make another type of class for another adapter, right? That's also one more case. So if you see a bridge pattern, you may be able to add or may be able to abstract it to another level, not making it just one adapter one-to-one, maybe like expand it. So I would say like if you're getting what I'm trying to explain, not making one-to-one, adapter makes it one-to-one because there is one thing getting compatible with one other thing. Whereas if you use another type of pattern like decorator, pizza topping, multiple toppings, you're using the same thing but just adding stuff on it. So basically, again, you need to understand what type of use case you're trying to solve. So if you just, that's why this talk is super important, because you just can't pick and just throw some sort of design pattern and think of, oh, I'm using a design pattern, so my design looks really good. So the problem statement should be clear to you. So, yeah.
Okay, I agree with you in thinking that in software design it's very important to apply design patterns.
Of course.
It's very important. Thank you very much, Tanu. We can. Now we can go to lunch.
Most awaited part of the day. Yeah, yeah.
One slide, you have the aggregation
Yeah, aggregation.
symbol, which is the diamond. But in the text below it says aggregation, but it's strong composition. But the text says it's hollow, but the image shows it
1, 2, 1, 2. All good.
Thank you. 30 seconds to go. I don't know, how much precise should I be? Not so much. We can go, right? Okay, so just a friendly reminder, you can ask questions on Slido. Okay, go on pycon.it/Slido. We are in the room Spaghetti. The question will be moderated. You can upvote, and then I'll read them to you. Okay, so it's a pleasure to introduce Jan. He's backend lead at REN and CEO at Jacosoft.
So yeah, welcome everyone. Thank you all for being here. It's great to share such a full room with you. Today we'll be talking about efficient fast API testing with PyTest, dependency injection, and snapshots. But before we jump into the topic itself, let me just quickly introduce myself. So yeah, my name is Jan. I'm staff software engineer and backend lead at ran.co. I'm also author of several tutorials and courses at testdriven.io, and I'm CEO at Jacosoft, my own consulting company. You can find me on Twitter and LinkedIn if you want. And yeah, that's quickly about me. Let's start at the beginning. So let's play a little game called Have You Ever? So raise your hand if you have ever restarted CI/CD pipeline job to pass a flaky test. Have you ever had to update lots of tests, maybe even thousands, just because you've introduced a small change, adding a single attribute to a model, maybe? Have you ever hoped and prayed for the test in CI/CD to pipeline to finish much, much, much faster? Have you ever had a broken production and green pipeline in CI/CD? So, okay, I see we are all on the same page. Same problems all over the place. So I hope you'll learn something new today, how to avoid that situations. So let's start at the beginning. Why do we even do automated testing? What's the purpose of that? The first thing, at least for me, is to protect against regression. So once we have something built, we want it to work always, right? We don't want in 2 weeks for someone to introduce some change and then all of a sudden everything goes kaboom. We also want to have much faster feedback loop. It can be very cumbersome and time-consuming to spin up the application server, to spin up maybe even UI and whatnot, and try to really go through all the flows that should be covered to make sure that things are working. So with automated tests, we can tell a computer, do that, try this scenario, this scenario, this scenario, and it does that because computers are very good at following the rules. If we say do that, they'll do exactly that. And we also use automated tests to verify our expectations so that our calculations are correct, that we are sending data to our analytics, that we are sending data to our CRMs and whatnot. But as we do that, we also encounter pretty common problems with automated tests. You've raised hands basically for any point that I asked. So yeah, that's because many times these tests take forever to run. When you have 10, 20, 30, 50, 100 tests, things seem to be great and they execute very fast. But if you have tens, thousands of tests, these things can become pretty slow, right? The next thing that's pretty common is that tests need to be updated every time that we change something inside the implementation. So these are tests that are not resistant to refactoring. For example, quite common cases in Python world when overusing monkey patching, and then all of a sudden you move module A to a place C instead of place B, and everything is red. And you need to go and update shitload of tests. The next problem that's quite common is also that tests are many times hard to read. I don't know about you, but I've encountered many tests that were like 3 screens long because there was this data and this data and that data and that data, and 70% of it was usually irrelevant for the test itself. And the last but not least, flaky tests. These are probably the worst because we can trust in our test suite. We can say, okay, if we have a green pipeline, things are working as expected, so let's just release to production. We are always a bit worried that maybe if everything is green, things might not be still as expected. But if pipeline is red, then we just go and try and restart and hope for the best. So let's talk about valuable tests that are not giving us the hard time and all these problems. So first thing, they protect us against regression. If we have tests that pass, but things are broken in production, that's not a good sign, and that's something we want to avoid, right? So we want to make sure that green test suit means things are working as expected. We haven't broken anything that was already there, so all good. The next thing is we want them to be fast. As I mentioned, if 10,000 tests need 30 minutes to execute, no one will ever execute them. Or they'll just sit and wait and hope for the best. They'll do context switching, because if you need to wait for 30 minutes for a CI/CD pipeline to pass, then you just go and pick some other task. The next thing is we want these tests to be reliable, so not flaky. If we execute tests 1,000 times, we want to have 1,000 times the same result. The next thing is repeatable. So if I execute the test on my machine, I want to have the same result as if I execute it on CI/CD server or if you execute it on your machine. I want them to be resistant to refactoring. If behavior that was there before is still there and just the code structure has changed, I want the test to still pass. I don't want to update them every time there is a slight change in the implementation itself. If there are new things added, I want to add new tests. If existing things have changed because there is new requirement now, okay, I'll go and change that. But I certainly don't want to update something just because I'm using, I don't know, Pydantic model instead of something else, instead of plain Python class. And another thing is I want tests to be readable. If you go and you see a failing test and you have no clue what the test is about, it's very hard to navigate and decide, okay, what's the problem now? Is this something that's flaky? Is this something that's failing for a reason? Is this something that's not even relevant anymore? So we want them to be readable, so when I see a test, I know what it is about and whether things are failing, why they are failing, and if they are succeeding, why they are succeeding. We also want tests to be resistant to unrelated changes. As I mentioned, if we have existing test suite and we add additional attribute to a model, we don't want 10,000 tests or 1,000 tests to fail all of a sudden, because the tests were there before, the existing attributes were there before, so these tests that are there already are non-relevant for this change. So we want to avoid it. And we also want the test to be true, which means we want to make sure that we cover happy paths, we cover edge cases, invalid cases, and so on. For example, if we are validating email address, we want to test also with subdomains. We also test with special characters like apostrophes and stuff like that. We want to case for case insensitivity and so on and so on. So let's continue by taking a look into Fast API application. That's a very simple one. I'll need to sit down so I'll be able to navigate the code a bit better. And we'll do two things. So we'll add a new required attribute to the model, and we'll remove existing attribute from the response, and we'll observe what happens. So that's a very simple to-do API built with Fast API. So let's start at the model. Do you see it, or should I increase the font size? Okay. Just give me a second. No. Thank you. Yeah, that's the beauty of my laptop, which does not collaborate well when increasing the. Let me try to use the view. Yeah. There should be presentation note somewhere. Command Shift. No. Yeah.
Increase font size in all editors.
Yeah, sure. So
Fourth
from the last, increase font size for all editors. Okay, let me do that. So one more time. Okay, better now?
Yeah.
One more time. Okay. You should see it now, right? Okay. So that's a very simple to-do model. So we have ID, that's auto-incremented integer, title, description, and completed flag. Then we have API schemas, so one to create a new to-do item, one to update existing one, and then we have a read schema, which is used to return the to-do items from the API. Then we have a simple database setup with SQLite. Then we have CRUD functions to list to-dos, get one by ID, create a new one, update existing one, and delete existing one by ID. So nothing special. If you've ever used the official Fast API tutorial, you should have seen something similar there as well. And then there is the API itself. So we don't deal with migrations. We just use the create all thingy from SQL Alchemy. Then there is getDB dependency function, and then we just use these CRUD functions to create our to-do items from the API schemas sent in requests. So we have create, read all, so which is a list, read by ID, update by ID, and delete. So nothing very special, one could say, but should be enough to prove the point. So let's now execute the test. So I just have a makefile because I don't feel like typing everything all the time. So this is the UTI is executing tests in here. UTE will be executing tests in here later on. So now we can see there are 5 tests. They all pass. OK, perfect. So let's take a look at these tests. So the first thing here is we have tests set up for SQL Alchemy. So we are using the in-memory one to make things a bit faster. And then we use dependency overrides provided by Fast API, which allows us to override dependencies. And we replace the original getDB function, which is defined here, with this override getDB defined in the test, so that we are using the test setup for SQLite. Then we have auto-used fixture to set up database, to create and drop all tables. And then we have database session, which we use then inside a test to pre-fill the data. So here is a test to create to do. So we send some data, we assert status, we assert that the title is as expected, and since we are using auto-incremented IDs and we don't know in advance what the ID will be, we just assert that ID is inside the return data. So nothing very complicated. And something similar then for to-do, but here we first pre-fill the database, so we add single row with a to-do item, and then we assert that the ID is the same one as we got from the database when adding it, and then we also assert that title is as expected. Something similar for update, so we pre-fill the database, we assert the status code, and then we assert that completed, which is by default false, as you can see here, is updated to the value of true. And then we have also the delete endpoint, so same story here. And then there is a list endpoint where we also pre-fill the database, and then we assert that we get a list, and here we got a bit creative, so we are using the read schema to make sure that all the returned objects have the schema shape as expected, and that's what we can see. So when we execute the test, they're all passing. Okay, so as I said earlier, let's now see what will happen if we add an attribute to the model itself. So here we have a priority. We just decided, okay, we want to have priorities for all the to-do items, and this is now a required attribute, so it should be provided when things are created, so we can't leave it to null. Let's execute the test now. Whew, everything is failing. So let's see. on create side. This is somehow expected because the priority is not provided, so let's fix that inside the main.py. So let's go here. We need to go to the create to do, and here we can say priority equals 1, because that's what we decide as the default one before we do any API changes. And if we run the tests again, the create one is not failing. Okay, so all good up to this point. But then we go to the get, update, delete, and list test. Here we can see that getting the to-do hasn't changed even a single bit. We haven't changed the schema, so nothing about priority is relevant. What's the problem here? So we are pre-filling to-do items. And since we are not using priority here, the test is failing. So if we add priority, the test will pass. And if we do the same for update and for delete and for list as well, now we'll have a green test suit once again. But as I said earlier, right, so that's not something we want to deal with because that's a very small example. There are like 3 tests that I had to update for no good reason. But what if there would be 300 such tests? I could lose 2-3 hours for nothing, to gain virtually nothing. So we would want to avoid it. So that's the first thing. Let me roll all the changes back. We'll take a look at how to do that more efficiently a bit later. So now let's try to do the following thing. So let's say, okay, I accidentally deleted the description from the read schema because I was just clicking some buttons and it's not there anymore, and let's run the tests. They all pass. The test suit is green, although we've just introduced breaking change. If we would have iOS client depending on the API schema and reading the description filled out, everything would explode. And we would have a huge mess on production, which tends to be very, very keen to do that exactly on Friday evening. So that's certainly not a good thing. And why this happens? So as you can see here, I verified only that the ID is present and that the title is as expected. There is no verification about the description, right? So these tests are certainly not true. And since we don't know the ID in advance, it would be quite clunky to do anything like that to make sure that we compare the full response, right? This would be better, but with many attributes could get very unreadable. But since we don't know this ID upfront, at least not reliably, we could say that it should be 1, but if we change the order of test execution, it might be 2, 3, 4. We can do that. Okay, so now let's take a look. What can we do to improve the situation? How can we do that a bit more efficiently? So the first thing that we can do is we can use factory fixtures. If you have used PyTest before, I'm sure you know fixtures, but taken from the PyTest official webpage. And so in texting, fixture is provides defined, reliable, and consistent context for the tests. In other words, in PyTest, these are functions with PyTest fixture decorator, which are executed by the PyTest itself, and their result is then returned to the test using them. By default, the fixtures are static, right? So you can return some string, you can return some email, you can return to-do items. So one thing that we could improve in our existing example, we could replace the pre-filling of database with some fixture. But the problem there is that many times we need to just slightly alter small parts of data to cover all the cases, as we want our test to be true. And in such case, the static fixtures can be pretty painful to deal with, because then again we might have 1,000 tests, 1,000 fixtures, and then again if we need to add priority to every fixture, that's pain in the ass. Factory fixtures, on the other hand, are callable. So instead of returning the fixed result, we can return a function which takes keyword arguments and returns an object that we need with some sane defaults, and we provide just the overrides that we want to deal with. For example, if we want to have to do in completed state, then we would just provide completed. Everything else would depend on the same defaults that are there to be used. This can improve the readability and also resistance to unrelated changes. The next thing that we can leverage are snapshots. So snapshots are captures of the output of tests at some certain point in time, and then we store them usually in text, bytes, images, so some external file format, and then we compare text execution now with the result that was captured when we were sure that things are working as expected. This is quite popular in UI testing for iOS, for example. In Python, I haven't seen that this much, but can be very useful when dealing with API tests. The great thing there is that we can automatically update the snapshots. For PyTest, there is a plugin called Syropy, which provides CLI option to update all the mismatched snapshots. So for example, if we add a new attribute to the schema response, and that's something that we want to do, we'll see all the tests with the old snapshots will fail. We can check what the diff is, and if it's expected, then we just go, we add CLI option, we update the snapshots, we commit that to Git, and then from thereafter we'll have new snapshots, and every time the test result will be compared to the new ones. It also provides snapshot features, so we don't need to deal with reading these files and loading them and whatnot. So there is just a snapshot feature, and we can just assert, for example, response.json equals snapshot. We'll take a look at the actual usage slightly later. And the third, so the last but not least, is dependency injection. So dependency injection allows us to inject selected dependencies when object is created. So for example, instead of importing something, we can provide instance of use dependency, for example, a repository which is responsible for data persistence stuff at runtime when some object depending on the repository is created, which makes it very powerful because it's very easy to swap different implementations. So for example, we can use much simpler and much more performant implementation for tests, and a real one, for example, that's actually using the database when the application server is running. If we can ensure that they're both having same interface and that they're both having the same behavior, at least during the test time, then we should be fine. And Fast API, fortunately, comes with very easy to use and very powerful dependency injection framework. If you ever use Java, you probably know that there are very, very hard to use and messy dependency injection framework, but Fast API one is really just like, yeah, use that function with type hint depends, and you can even use annotate to simplify things even further, and that's about it. So let's take a look, if we use these three things, how we can implement the same API with Fast API, but make testing much more efficient. I hope that the font size is still the same as before. So as before, we have the same model. We replaced the auto-incremented integer with a string because SQLite does not have UID type, but we'll use UIDs. Then we have same as before, so nothing has changed there. So create, update, read one. Then we have the database set up as before, so this is still the same. And then we have dependency, which is now two functions. So instead of having the database session used directly, we use repository. And we also use UID provider, which is a very simple thing here. So it's just a wrapper around actual UID provided by standard library in Python. And there is this one which is called fixed UID provider, to which we can provide some specific value, and every time that we call it, we'll get the same value, which can be very useful in tests to assert things with static values instead of having a new ID value, especially with snapshots, as I mentioned. This can come very handy. We'll take a look into this slightly later. So then we have repository, as I mentioned here. So instead of using the database session directly in the API, we'll use repository. And it looks like that. So we have the abstract class, which defines which methods should be implemented here. And then we have two implementation, the in-memory one and the SQLite one. The SQLite one is pretty much the same as the CRUD functions previously. And the in-memory one exposes exactly the same behavior as SQLite, but it just uses plain Python objects like dictionaries and so on to store these values. Obviously, if we would use in-memory implementation on an application server, every time that it would restart a server, we would lose all the data. So certainly not suitable to deploy with that one. But during test time, which is quite limited, and we are always creating new database and then we are dropping all the data out, we can achieve exactly the same behavior. That's easier said than done, so we want to test that. And we can test that with contract test. So we can define set of tests that needs to pass for all the implementations. So here is the first one, where we say, okay, if we add to the repository, we need to be able to get it back by ID. So the thing here needs to be exactly the same when we fetch it from database, and we want to be able to also list the to-dos once they are added. And we also want to make sure that once the to-do is deleted, and the exception is right because it's not there anymore. Once we have such contract, we can then use the test classes to just implement the fixture, which is here not implemented, so it will just raise an error. And here we just create a new instance of the in-memory one. And for the SQLite, we obviously need also the SQLite database connection and so on. We need to create tables and we want to drop them. So we add this part and then we return the instance of SQLite repository. So a bit of an overhead, but this can simplify things inside the API testing later. So let's go further. Let's take a look at the tests now. So now we have, as you can see, create, and snapshot fixtures used. So let's go to the conf test to see what's happening there. So these are now factory fixtures, as mentioned before. So instead of returning just a static value, we return a function, which is returned here. And by default, we set some same defaults, but we can always provide keyword arguments to override them as appropriate. And here, for example, in the repository test, we can just use the same defaults. Nothing is really relevant, so we just want to make sure whatever is added can be fetched back. So we don't provide any overrides, but if they're relevant, we can do that. And then we have a similar thing to creating the repository, so we can provide to-do items via keyword arguments, and we can use them to pre-fill the repository. And then there is the create API client factory fixture, to which we can provide the dependencies that we want to override, and they are overridden for a test time, and then they are cleared at the end. So let's go back here. So now here we can see we are using the fixed UID provider, so there is some fixed UID value. And now anytime that this one will be called, we'll just return this value here. And we also override the to-do repository to make sure that we are getting the in-memory one. instead of the SQLite one, which is returned by default by this dependency function. And then something similar for reading all to-dos. We improve the test here by adding 2 to-dos instead of only 1. And similar for read, similar for update and delete as well. So here, as I mentioned earlier, we can just say that the response JSON equals the snapshot, and we can take a look at the snapshot. This is how it looks like for the test create to do. That's what we expect to be returned. And then for the read, read all, read, update, and so on. For the delete one, there is no snapshot because we just assert that there is status no content. So let's run the test now. Okay, now we have 9 tests, which is more than before, but they're all passing. And if we now go and do the same thing, so let's add priority to the to-do model. I also need to import integer. What happens now? So now only 2 tests out of 9 are failing, and these are the repository tests. We can go, we see, okay, so it's a not null constraint on the priority. We go here, we see, we are using the factory fixture for creating to-do. Where is the contest? So it's here. We can just say, okay, let's add some sane default for that. And there we go. We are back at the green test suite by just adding a single line. So now if we have 1,000 tests using this factory feature for creating to-do, we still need to update 1 line to make it sure that all of them are passing. If there are new tests that are relevant for the priority itself, then we can add them and we can alter the priority there as expected. But for the existing tests, priority is not relevant, so we can just make sure that they are still passing. And then if we go and we do something stupid again, so I delete the description because I was sloppy, and we run the things again, we can see that now all the API tests that are using the read schema are failing because there is a diff in snapshot. We can check here. Minus means that this thing is missing. So description is missing here, and it's missing here. That's not what was intended. Oh, look, here the description is missing. I can just return it, and if I run the tests again, they're green. And if I would need to now add some new attribute because some requirements just came in, I can do this. I can add it, and then I'll see that the tests are failing. But now I check and I see, oh, yeah, that's the new attribute. I'm fine with it, so I want to update that in all the snapshots because it's safe. I can then use the CLI option provided by SyropI, so poetry run PyTest snapshot update. So that's the CLI flag, so snapshot update. I can run it now, and then I can happily run the tests as so far. So as you can see, it's very easy to update the snapshots when changes are intended, and they also caught the issues that were introduced by some unintentional changes. Last but not least, let's compare the efficient and non-efficient tests. So I already mentioned, so here we have 9 instead of 5 tests, but if we compare the execution times, we can see that despite using the in-memory SQLite, these tests take roughly 12 times more to execute, right? Yeah, okay, now I have, let me update the snapshots again. So you can see, right, so it's 0.4 instead of 0.35, right? So it's a significant difference. Here, that won't impact anything, right? Both executions are instant, but if you multiply that by 1,000 or 10,000, the difference can be significant. So the efficient tests also prevented the regression. As we were able to see, the efficient tests were resistant to unrelated changes, right? So we were able to very easily make them pass by adding a single line to the factory fixture. And we also made sure that tests are more readable because we don't deal with all the database crap and whatnot. Obviously, with the least test, things are a bit longer than before because we've added 2 to-dos instead of 1, and we also wanted them to be different in title, description, and completed flag, but we could also just use the same defaults and still make sure that 2 are returned and so on. So, yeah, that's about it. Maybe just one thing to conclude before we jump up to questions. So, I presented a couple of methods and approaches that you can use. Don't take them as silver bullet. If you have 100 tests for a very simple API that just wraps some ML model and have some settings there and so on, you might not get all the benefits or they will be neglectable. So no need to just go home and just take a stab at everything and update it to these patterns. And if you want to apply these things to your existing projects, never go and throw everything around and start updating everything. Take a small feature that comes your way and maybe do some experiments there to see how things work in your context, with your use cases, with your requirements, with your knowledge, and so on. And then once you can confirm, okay, this is what I need, this will improve my situation, then you can go and slowly update the things to be done that way. But don't just go and jump straight on your head because you'll just lose your teeth. That's it, so time for questions.
Oh, thank you very much. So we have quite a few questions. First one, how do you manage properly the independence of the tests? For example, we created a to-do model in our DB for one test. How do you make sure the model does not interfere with other tests?
So usually it's the easiest if you ensure that things with fixtures. So if you do anything, always clear the things up. That's why you have the yield option in fixtures, so you can do some things before the tests are executed. You can yield your data persistence, whatever it is, and then after the yield you can do the cleanup and make sure that there is nothing left. So the next test is always running inside the clean things as expected.
Next one, how do you type hint factory fixtures, especially the ones using keyword arguments?
So for the keyword arguments, to be honest, I never type them because that's just the investment I'm not willing to put in. Yeah, I mean, it's a test code, so if something is off, so be it. But I do always type the output, so you can use callable, and then whatever, and then the return types. And then here inside the function that's returning, you just define the type as you would use with the regular feature. And that's it. I wouldn't go down the rabbit hole of type hinting the keyword arguments because already in the production code, this can be a significant pain in the ass.
Okay,
that's it.
Next one. When should we use dependency injection overrides for test versus unit test mock patch functionalities?
So I usually try to avoid the mocking if possible. It's not possible all the time. For example, if you are using some integrations to third-party systems like CRM, what I like to do there is to create a wrapper around the CRM integration, even if there is some SDK for, I don't know, for Mixpanel or HubSpot or stuff like that, which has a very simple interface which can be used from any code that has some business logic. And then I use create autospec to create object with exactly the same interface as the original one, and then I mock from there. Because if you use magic mock, it's very easy to end up with tests that are passing, but the things have changed since then, and then it's pain in the ass. But with everything else, if you can gain a control by injecting something, especially the code that you wrote, I wouldn't go and inject SDK for Mixpanel, which is some third-party library, because this can be a nightmare. But the code that you wrote, if you inject it, because that gives you more control during testing, and you just need some factory function which ties together all these different objects into a usable object for running the application on application server, then I would do that. So yeah, don't mock if you're not forced to. And when you are using mocks, try to mock your code, not someone else's code, because it's a nightmare when there are breaking changes. Just had to deal with something with breaking changes in Stripe SDK, and yeah, I lost quite some blood and sweat.
Okay, thank you. Luca asks, I understand what you are doing with factory fixtures, but I'm unclear about what is happening with snapshots and dependency injection. How do factory fixtures, snapshots, and dependency injection interoperate?
Okay, so let's maybe go to one of the tests. So factory fixture, let's go maybe to the this one, the read one. So the factory fixture for creating to-do is used to create an object as we would like it to have, and we provide some overrides here. By providing the ID value, we make sure that the snapshot will be happy because it's always the same ID whenever we run the test. Then we use factory fixture for creating repository to pre-fill these to-dos to repository, and then once we have the repository in the desired state, then we provide it to the dependency overrides, which then goes to regular fast API dependency injection. So by doing that, we say, okay, instead of using whatever this function is returning, which is defined here, instead of that, return the function, which is in this case lambda, because we don't need anything else, that's returning this repository which we put into the desired state. Okay, so when you call the API by using the test client, when fast API here in the main.py here, when it calls this get-to-do repository by its dependency injection framework, it won't return the SQLite one, which is defined here, but it will return this one that's defined inside this lambda function. So this is how these things interoperate and make sure that you have the full control all the time, so you can set the values that are ever changing, for example, the UID to some fixed value to make sure that snapshot is happy. And if you don't have snapshot, the test will fail, and with update snapshot CLI flag, you can make sure to create the first one. And then you get something like that inside the snapshot file. SyropI will read that, and then here it will compare whether the JSON returned in the API response matches the JSON specified in the snapshot file. Hopefully that explains it a bit better.
Okay, thank you. We still have time, so a couple of questions left. What is your general takeover on VCR, especially when the API returns a huge page load?
VCR, what's the VCR?
You know, when you run a test that has PyTest VCR as a declarator, you can say there's a YAML what the API has returned, like the HTTP request.
Yeah, you save the HTTP request as a YAML file.
Yeah.
And then when you rerun the test, instead of doing another HTTP request to the API that maybe is flaky or whatever, it basically gives you the same payload.
Okay, yeah, so that's something similar as a response library for mocking the requests, where you can also specify, yeah. Yeah, I mean, if you need to actually test the part that interacts with the third-party API, yeah, go on and use these libraries. They can be super handy. But nowadays, I usually, if they are very easy to use and it's easy to verify them by running just all the methods that are on the integration itself, by having some script, I do that. And then if the frequency of changes with the integrations is very low, so this is updated, and when there are breaking changes in the API, I just don't mind adding additional tests there because everything is pushed into some corner, and if there are no updates, then who cares?
And yes, PCRPy is fully automatic, so it updates the integrations for you, the mocks, and it creates the mocks for you automatically.
Yeah, sure. So if you need it, go on and use it.
Okay, we are.
But I've never used it myself, so hard to actually compare it to anything that I was just saying.
Okay, we are over with time. Thank you very much, Jan.
Thank you.
One, two, three. 1, 2, 3. 1, 2, 3. I think everybody can hear me. Huh? No, I'll be a little bit louder.
Will you speak louder?
Yeah, we'll speak louder.
Okay.
Yeah.
So try as you would.
Okay, 1, 2, 3. 1, 2, 3. That is pretty much my voice. Good.
Welcome everybody to this talk of Stanislav about unit testing and anti-patterns while adopting this practice. So let's give a warm welcome to Stanislav.
Hello, everyone. My name is Stanislav Zmiev, and today I'm going to be talking about the worst ways to test and some of the modern infrastructure that you probably didn't hear about, or at least not about all of it, that could help you out. But first, it's really funny because Jan has a very similar topic, although we have very different takes on it, and there is a little bit of a competition. So if I win, just clap at the end. So, I work as a tech lead at SEMA Software. What we do is we help product and engineering teams stay on track of their roadmap and reduce the number of meetings in the companies by ingesting all of the company information into AI, summarizing it, correlating all of it, and at the end, giving everyone the transparency about what's going on in the company without tracking the metrics of individual developers, because, you know, who does that? This is the link to the slides if you would like to follow them with your phone, but let us start with the most important question. Everybody talks about unit tests. Everybody likes unit tests, but what are unit tests? And specifically, what are units? Please, shout it out. Anyone. What are units?
Functions, classes, modules.
Okay, functions, classes, modules. Anything else? Any other guesses? Okay. So if unit tests are tests for functions and classes and modules, then component tests would be tests for components, like something bigger than modules, and integration tests would be tests for what? Maybe we use the database in integration tests, or maybe we use the external services, such as, I don't know, OpenAI in our integration tests. But then the system tests would be testing what? Oh, well, the entire workflow, probably. This is one of the most common definitions of unit tests and of the testing pyramids. And this definition is also absolutely useless. I do not like it. I do not like it for so many reasons. The main one being, if we say that unit tests are strictly for functions, then everything else, all of our definitions and the way we write tests for different products is going to be a little bit skewed towards very, very small tests for individual functions. Those tests can break a lot. The reason I'm calling it useless is we first have to define how is this pyramid helpful to us? In order to define that, we need to understand, why do we write tests? And that's the next question. Why do you write tests? Shout it out. Anybody? Refactoring. Okay, refactoring is easier when we write unit tests. Okay, anybody else?
To ensure the code works.
The code works. Okay, ensuring the code works.
Document the code.
Huh?
Document the code.
Documenting the code. Amazing reason. Yes.
Satisfy code coverage tools.
That's one of the best reasons.
For managers.
For managers, even better. If your manager is not a technical person and they're tracking your code coverage, I pity you. And even if they're technical, really. So for me, the two main reasons for writing the tests is to know when my public interface changed, and sometimes to explore. To just explore the options and to think in code. That's it. Everything else is likely going to be either a side effect of this or in contrast with this. So the right tests should speed us up. As you mentioned, with refactoring, when we write tests to our public interface, it's going to be really easy to refactor. But if your units are functions, and you are writing a graphical user interface, and you rewrite those functions during refactoring, guess what? Your tests will break. We don't want that. We don't want to live like that. So I define a unit as something a little bit more volatile, as not just a function or not just a class, but something that depends on your product. Specifically, if your public interface to your product is a function, such as when you have a library, then yeah, your units are going to be functions. Those functions that your users are using. For example, in path walk, your interface is a function in pathlib. Or in OS, I don't know, less dear. Your public interface is your function because your clients are other programmers that are using it. When you're writing a graphical user interface, your public interface is going to be widgets. You need to test widgets. You don't need to test the internal implementation details of how you interact with business logic underneath those widgets. And in your API, it's going to be endpoints. You're going to be testing endpoints. You care about endpoints working, and your public interfaces in endpoints not getting broken. So the problem with defining it as a public interface is public interface, as per Hiram's law, is anything. After a certain amount of time, your spacebar key heating up because you're pressing on it too long is going to become a public interface, because every visible behavior will at some point be depended by someone. So the more code we have, the more history we have, the more users we have, the more things are going to be becoming public interfaces. Now, if we define our units as public interfaces, how do we define our integration tests and component tests? Simple, you don't. Because the purpose of integration tests and component tests takes deep roots in history. I recommend reading Martin Fowler on this, but long story short is that in the 80s, when we used waterfall, when we could write the software for a long time before we deployed it, before we tested it, one person would sit down, have the design document, and then that person would write their module for a long time. It would be, maybe it was a package, maybe it was just a huge module, and the person would write it for months. And then after those months, you would need not just the unit tests that this person wrote for their module, but some tests that would verify that the other modules, also written in isolation, would match it. The interfaces between them would match. That's the purpose. How often do you have most of your developers just sit down in isolation, write something for 3 months? Please, raise your hand. Anyone? Okay. So sometimes that happens, but most of the time, in modern development, we use agile, we use trunk-based development, we use so many other buzzwords. But the goal of this is to, continuous integration, continuous delivery, to make the integrations and to make such iterations really small. And as a result, because they're small, you don't really need that layer of component tests of integration tests most of the time. But of course, it depends on the product. So what I propose is to use the most classical testing pyramid, and even this one is wrong, and Martin Fowler critiques it right here, but the purpose of it is not the specific layers. The purpose of it is to say, well, okay, most of your tests should be fast, and most of your tests should be relatively isolated. While the higher level tests, of which you have few, are going to be less, more integrated and are going to be slower. That's it. That's the entire testing pyramid that I'm proposing. Anything else, any more detail than that, is probably not going to fit some product or the other. Now, if you remember Kent Beck, the author of TDD, you might expect him to say, well, we need 100% coverage, or you can just cover your public interfaces, you got to cover everything. In fact, that guy said the opposite. I think it was in 2008 or something, where he specifically said he's not getting paid to write the tests. He's only verifying the things that he's worried about breaking. And building on that point, whenever I write tests, I usually don't write them because I'm afraid of breaking my new code right now. My new code I'll probably also verify by hand or by a myriad of other things. No, I am writing my tests because I'm worried that someone else in the future, 2 months from now, is going to break this public interface. That is a much better reason to write them. But getting back to Kent, he mentioned that 10 or 20 years from now, we'll likely have a more universal theory of testing, where we would be able to understand the trade-offs and the different ways we could write tests a little better. Thing is, 10 or 20 years from now, which from then, which I think is like closer to like 18 years, 16 years, he actually came up with it. He called it test desiderata. He has a bunch of videos on it, and there are a bunch of articles. I'm not a huge fan of their examples, but the concept itself is super important. he essentially wrote this to explain that the tests, all of these are desirable properties for tests. For example, we want them to be fast. We want them to be readable. We want them to be predictive of failures. We want them to be, what else is there? Specific, right? We want all the tests to be this. Problem is, these properties are conflicting with each other. All of them. All of them are conflicting with one or more other properties. And the purpose of desiderata in this presentation is to show you that it's an art. There is no right way to write tests. There's only the trade-offs that you would take from desiderata. So whenever you're writing new tests, always think about, okay, which properties from these would I like to pick? And more importantly, which properties would I not like to pick? And as I said, there is no right way to write tests, but there definitely is the wrong way to write tests. If you pick the wrong trade-offs, that is going to be terrifyingly bad. And as per the previous presentation, every one of you has probably seen situations where all of your tests break because of an unbreaking change. You extended your schema, and no clients would be broken by this, but your test broke. Or the reverse. If you write your tests, but then some bug surfaces on production because your tests were too granular. They were testing logic at too low of a level. Moving on. Let's recap. Tests should be speeding up your work. The fact that tests are slowing you down, we don't need tests because we need to move fast, I think that's bullcrap. Tests are supposed to speed up your work, and good tests would allow you to refactor faster, to fix the bugs faster, and to iterate and experiment faster. Unit size always depends on the product and on the public interface, on how your clients are using your product. And then there is no right way to do tests, but as I said, there is a wrong way to do tests. If you forget everything from my presentation, every single thing, please remember this. Just this is going to improve the quality of the tests at your company by, I don't know, 100x. In some cases, it makes useless tests into useful tests. But to help you, I'm going to propose a few pieces of infrastructure that significantly simplify following those rules. Let us build the e-commerce API. It's not a pretty API. It makes some mistakes, and it's just here for an example. But we have a few endpoints. We are going to be testing them. We wrote them. They have some bugs, and we're going to be playing around with it, making mistakes, and trying to write better tests. Let's focus on this first. What is a problem with this test? As you see, we are importing our order item from our DB models, and then we are importing some function from our services. And then we call this function with the specific DB models. Problem is, if this function stops being used, the test won't break, but the business logic might. If we make some mistake and our Pydantic model is going to fail to validate the response, the actual business logic will break, but this test won't. If the number of arguments and the arguments themselves or anything else about how we use this function is going to change, our business logic might not break, might be okay, but this test will break. And if you have hundreds of tests like this, then you're in trouble. So the best way to fix this is to use your public interfaces, like this. So you use, in FastAPI, it's the test client. In other environments, it might be something else. But you should always stay as close to your public interface as possible, unless you care about the speed more. In this case, the speed difference is tiny. But for example, when you're testing the graphical user interface, it's not going to be as tiny. And so we create the test client. Then we post the orders, and then we check the status code and the JSON. The thing about this is going to fail if we return 500, or if the response of these items changes. So we are still testing the core calculation logic. But thing is, if we refactor everything, if we rewrite every single thing, every single function, if we completely change the structure of our code, this test is still going to work super well. Problem is, you are not working alone. You might know this. You might be able to follow it. But what about your colleagues? dozens, hundreds, thousands of people committing to your repositories. What do you do about them? Well, thing is, there is the import linter package. It takes some rules, and you can write as many rules as you want, and it validates that some things are not importing other things. In essence, this is architectural linting. It allows you to lint your architecture, and in this case, we say source modules tests are forbidden from importing services, utils, and models. So now, if we run the import linter against our code base and we try to validate it, here's what we're going to get. Tests is not allowed to import SRC services, and this test does. It shows us the line where it does that. So now, you can do this for so much more than just tests. You can use this, for example, in a modular monolith. When you're saying, okay, I don't want these modules, like all of the modules in my monolith, to import each other. It has many kinds of rules, and it's like really fun thing. Moving on. If your units are too big, for example, if you are testing and you're testing multiple endpoints, multiple workflows, multiple scenarios in the same test, that's a problem. Because imagine if just this subtest failed. How would we rerun it? Just one subtest? We wouldn't, because we would need to rerun everything. And so there are many problems with this. The actual test that I based this on was 300 lines long. It was testing, actually more, I think it was more. It was testing so many scenarios. It was preparing common things for each subtest, and it was impossible to add things in there, and it was even harder to edit the existing tests if you needed to change or fix something. So whenever I see subtests, I usually the red flags rise, and I'm like, okay, there is probably something wrong. Most of the time, it means that you have picked too big of a unit. So how do you fix that? Well, you could split your tests into separate units and use fixtures to use fixture for common things. So simple. You would be able to know which exact test failed. You would be able to rerun that exact test, and each test is going to be easier to write and to read. It's okay if sometimes you just have a long workflow. You just have a really, really big workflow, and you want to test that exact workflow. In this case, as you see, this is just different things. This is different concepts, different workflows tested in the same test. But sometimes you'll just have a long workflow that creates a long test. It's okay. It's okay for your tests to be long. As I said, it's an art, not a science. And there are sometimes cases where your units are too big because of your product. So for example, this is Typer that allows you to create CLI interfaces. When I'm trying to test Typer, the default way is probably going to be invoking it like this. Which essentially, if any errors arise, I will see them in std out. So I wouldn't get a nice exception. I wouldn't get like a diff like I would with general PyTest. It is a pain in the ass to debug. Same goes for many UI tests. Which is why sometimes when your units are naturally too big, it might make sense to create the minimal thinnest testing layer, which is essentially what you do when you are properly following the clean architecture approach and you have a function mapped to your widget directly or mapped to your endpoint that has no logic of its own. That function essentially encapsulates everything related to it and calls all of the other pieces of business logic in your app. That's essentially this pattern. If your tests are really big and really hard to read and really slow and really hard to debug, that might be a solution. There is also the problem of asserting too much. Because, for example, let's take a look. We are patching the order status done, and this is something that I picked up in an actual code base. I remember a code base where adding any field has broken hundreds of tests every single time. And so, because we are asserting the entire JSON, this test is going to break no matter what we change, even if we're changing something that is completely unrelated to the test. So one of the ways to fix it is to just assert what you need to assert. However, this is a little bit too involved to write, especially if you're asserting many things. And also, it's not always easy. So let us start with our live demo. I'm going to show you another approach that could help you. Please tell me if you see everything clearly. Okay. Sorry for the screen being dark. Let's hope it's good enough. So we have an API. User create request, user resource, and we have the register user, and we have update order. So these endpoints are just returning duds, but we only care about our tests. Let's take a look at the first test. So this test doesn't have, actually, let's take a look at the too many asserts first. This test has too many asserts. So if, for example, I go to my app and I add something here, let's say delivery method. Oh, thank you, cursor. So I add delivery method. I run my tests. Something failed. Okay, delivery method error. And if I had hundreds of these tests, it would be a pain in the ass to fix every single one. Thankfully, cursor improves that, but let's see if we could improve that without even using cursor, because cursor would only be able to help you in a single file for a few tests. We use inline snapshot, the same library that is used by FastAPI and by the Pydantic team for their testing. And now let's run this test again. Boom. Take a look. It broke. But now it tells us, hey, we added a new field. Would you like to fix these snapshots? We say yes, and it fixes it. Take a look. Delivery method, error. That's it. It's that simple. So it allows you to immediately update those tests even if you are asserting too much. So essentially, it allows you to make this mistake, but it makes the price of mistakes so much smaller. Now, that's cool and all, but let's take a look at another problem. If we don't have enough asserts, so for example, here we're asserting our ID, we're asserting our created at, but we don't actually assert that created at is going to be now. And if anything here changes, we'll need to fix it by hand. So now, let's change it first. App, let's for example say that our username now becomes something else, whatever it is. And now, let's run this. Okay, our test failed. If we had many tests like these, they would all fail. Not nice. So now, let me first show you how to fix that. It's rather simple. As we saw before, we could do assert response JSON. Aw, that is spoilers. Give me 1 second. Who remembers how to disable cursors oh, yeah, I see it now. Disable globally. Now, if we just use the snapshot testing here, we would be able to reach the same thing, right? We would just add, actually, no. Now I need cursor, but no, it's going to spoil things. So if we just had ID, then something in ID, we don't know what, then we would have, give me 1 second. Okay, then we have the email. The email we can assert like this, really simple. Then we would have the username, and we could assign username to test example. Okay. And now the created at and updated at we can't really assert because that is not going to be easy. So here, okay, snapshot testing now did this again for us. Not super convenient. Let me split them like this. Boom. Okay. So it is showing to us that it fixed the username thing, but problem is we can't assert the whole JSON against the schema. So okay, let us return to the old test, the original test. Let's take a look. We still are going to use snapshots, but now just for individual values. Boom, boom. It's nice, but it's not nice enough. Because now we'll just have to add snapshot to every single field. And if it's many fields, it's going to be painful. So another thing that we could do to first of all verify that our ID and created updated at are still tested, if we do need to test them, and to make the testing code much nicer is to use dirty equals. Dirty equals is the library, I think it's from Samuel Colvin, which allows you to assert things much more nicely. Is UUID, and if you saw the previous presentation, they did a similar thing, but without dirty equals. You had to implement a lot of code. So now let's say created at is now, and it's going to be ISO string equals true. Okay? Okay. Now let's change this to what it was by test. Can we put this into a snapshot? Fixing it. Now, and the ID we would validate with is UUID. V4, I think it's like this. Yeah. So now this test is still going to pass, and if we start returning something else than the UUID, it would break. And if we start returning something else than now and a proper datetime, it would break. In this case, not super useful, doesn't look as nice. The reason we added this and the reason combining dirty equals and snapshot testing is useful is because, and now I'm going to turn on my cursor tab because I'm sure that it's going to help me with this. Assert response.json equals the snapshot. Yes, and now ID, oh, thank you. It's because of this. Because now, as you see, our testing code is declarative. It is much easier to read, well, arguably, and at the same time, it's going to update if anything breaks, anything changes. And because we put ID into EasyUID, we can make it a part of that equals. So let me change something else now. Let's return the body email by test. Take a look. So it knows, it can work with dirty equals. We can understand that that ID must be EasyUID4, but at the same time, the username is fixed. And now when we click yes, it's going to change that for us. That's it for the live demo. Let us go back to our slides. Now, there is another anti-pattern. Whenever you are a startup or whenever you're prototyping and you're trying to cover everything with tests, you're trying to just get 100% coverage because you want, I don't know, to satisfy your manager, or because you want this, this certainty that everything works, why? If something is expected to change, if the public interface is expected to change, is expected to break a lot, why would we write tests for it? The tests are there for the future regressions. Well, the simple solutions to this is don't. But something more involved would be coverage exclusion. So you can list in your coverage config all of the things that we don't want to be included in coverage. And as you see, things like wrapper or rich wrapper might not be something worth it to test. In some cases, if you're making a library and you're expected to be using these, it might make sense to include them in your coverage. And in some cases, when you're making an API, maybe not. And this is actually the default recommended one by Coverage Py, but sadly, they don't actually make it a default. So you have to put it in every project of yours. And you can also omit some of the things that you don't care about, such as I don't test my docs plugin because if it breaks, I will find out immediately. My docs will stop working. And then there is the concept of clean coverage, which is essentially you do 100% coverage, but instead of actually covering it 100%, you ignore coverage, you put pragma no cover on everything that you consider to be volatile or not as important, like not a public interface or not a part, not something that you expect to break your public interface, and then everything else, everything that you care about, you cover. So you get 100% coverage, you get that sureness that every line has been looked at and the decision was made for every line, but you don't have to cover everything. And actually, when I was at PyCon in Germany, many people, authors of famous libraries such as Marcelo, such as some maintainers of PyTest, and many other people, and the author of Inline Snapshot, all of us were following clean coverage, but none of us knew about the name. Well, except Marcelo, he was actually the one who told me about it. Now, there is another problem of your tests being non-parallelizable or slow. Well, the problem is the tests being slow, because if your tests are slow, your iterations are slow, and it's really hard to work in general. If you make your tests, if you parallelize your tests, it's not going to be as big of an issue, because in CI, you would be able to parallelize across, like, I don't know, 90 CPU cores. On your computer, you would still be able to parallelize it and speed them up significantly. But if they're not parallelizable, for example, if the tests are using the same resources, and these resources will make the tests coupled, that is going to be an issue. You won't be able to speed up your tests. You won't be able to do anything. You will have to run them, I don't know, in different VMs. I have no idea. So one thing you could do is instead of using common resources, split them up, use more fixtures, use things that allow you to keep your tests isolated, and then use PyTest xdist to run your tests across many CPUs. Having your tests fast is an important quality of development. It's going to make your life easier, and it's going to allow you to run your tests more to have faster iterations. Really nice for releases. Now, there is another solution, especially if your tests are not fast enough. Even if you parallelize them, especially if you are in an old project and it has, I don't know, 5-10 million lines of code and, I don't know, 10,000 tests, it's still going to be slow. On your machine, it's still going to be quite slow to run all of these tests, even if you parallelize them. So one thing you could do is install PyTest testmon, which is going to essentially take the coverage information, and whenever you change anything, and whenever you write new code, it's only going to run the tests that are affected by that code. And it has a pretty nice theory on how it determines it, and it's pretty robust in how it determines it. So you get all of the safety of running everything, but at the same time, you only have to run a few tests. So for example, I edit one module, I have like 5,000 tests, but only 5 tests run. And you don't even need to think about this, because PyTest testmon does that all in the background for you. Really cute tool, especially good for huge projects. Moving on, if you mock too much, for example, if you mock your code that you were writing, some portions of it, for example, some controllers in your business logic, every time you're going to refactor them, you're going to run into trouble. You're going to run into problems. You'll have to refactor your tests as well. That is going to be incredibly painful. So I suggest do not mock your business logic. But then there is another problem. There is a database, which many people still mock. Who of you mock your database? Okay. Problem is, whenever you mock your database, anything database specific, anything that is related to the constraints, or that is related to, I don't know, parallelism in the database, or any internal interface, anything that is database specific and not specific to your mock is not going to be verified. And it would make sense if your database is incredibly hard to run. For example, if you're using DynamoDB, and you cannot really test, you cannot really run the database next to your code. It makes sense. But if you're using Postgres or Redis, you can run them next to you. And I advise to use Docker Compose on your local machine, and you could use something like test containers in your CI to run every container that you need next to your code. Test containers is incredibly easy to spin up, and it allows you to essentially programmatically spin up some container and then kill it. So you'd be able to spin up your Postgres really quickly just for your tests, then run your tests against the real Postgres. It's going to be fast. The file I/O is fairly fast, even if you have a lot of tests. And if it's not fast enough, parallelize. So I advise you to run against real database as much as you can, because it's not that slow, and it will allow you to omit all of those mocks. You won't need them anymore, and your code, your checks are going to be giving you more confidence. But there is another thing. I work in an application where we're calling a lot of LLMs and a lot of external providers, such as GitHub, such as Jira. And the problem is, whenever you're writing tests for that, you would need to mock all of them. If it's okay to sometimes mock Jira directly, I'm expecting it to return this, it's just one API call, it's not a problem. Whenever you're mocking an LLM, and if you are doing 100 requests to it, 200 requests to it, are you going to mock all of them? No. Most of the time, you're just not going to be testing it directly. You're just going to mock the entire interface and somehow try to make your tests work. What I suggest in this scenario is to use VCR-Py. It's super simple. As you see, you're just calling the endpoint, and then you can do whatever with it. You call your endpoints, you run your tests. It runs again. All of your tests will run against the real endpoints, the real LLM, the real integrations, whatever, the real HTTP URLs. And then VCR is going to record all of the responses based on the requests. It's like caching. And then, next time you run your tests, it's going to use that cache for every single request. So you get the speed of running the tests quickly against those mocks. You don't have to write those mocks yourself. And if you need to update those mocks, it's easy. VCR-Py has a mode where it refreshes things. So you're always up to date with your external integration. You don't need to think about their breaking changes. At the same time, you don't need to worry about mocks. You don't need to worry about writing them yourself. So yeah, almost free, almost. Moving on. As I mentioned previously, there is a lot of code, and I've seen this code, like this exact test, thousands of times, where a person would need the coverage, would want to cover something, but wouldn't really want to write the assertions, especially if there are a lot of assertions, and especially if they are hard to write. For example, if you expect your code to have some side effect, well, I suggest adding more assertions. Well, it's hard to add those assertions. It's hard to validate how many assertions are there per unit test. So everybody says coverage is not a useful metric on its own. What is another metric that we could add to it? Speed? No. What is a metric that would allow you to say, okay, these tests are actually asserting a lot, and if something changes, they would catch it? That metric is mutations, and specifically mutation testing. What mutation testing does is it takes all of your tests, it takes your code base, and it starts making small changes. For example, replacing more than with more than or equal to, or replacing one constant. For example, here we have an empty constant, replacing it with xxxx. It starts making those changes, so breaking your code base in many ways, and running the tests. So it makes one change, runs all the tests, and verifies. Has any of the tests failed? If yes, then the mutant didn't pass, and that's good. That means that your assertions are working, and that your tests are actually asserting everything. They're not just calling your endpoints, or not just calling your code. And it does that thousands of times. Depending on the size of your code base, it's going to be bigger and bigger and bigger and bigger amount of mutants. And of course, you don't need to get those mutants to zero. It's okay if you have some mutants. It's okay if you have something uncovered. But if you want a metric that tells you how good your coverage is, you should use mutation testing, and specifically mute in Python. Moving on. Oftentimes, your tests are really hard to write. Especially if you have to prepare a lot of things for your tests. And the problem with this approach is your tests become really big, they become hard to write, and they become even harder to read. So what we could do, oh yeah, this test is even bigger. So if you take a look, these are two tests. Yeah, where is it? These are two tests. The only thing different between them is this line, because a lot of code is duplicated, because it's not exactly easy to put into a fixture, because something is different. You can't just fixturize everything. In which case, you should use factory fixtures. The problem with factory fixtures is that they're really hard to type hint, which is why I created PyTest fixture classes. What it does is it gives you those tiny, nice fixtures, such as create order. As you see, it's the order fixture type, so it's type hinted. And then, as you see, the tests are now tiny. because you just create the order with status unpaid, so you can essentially customize your fixtures for every use case, while at the same time having at the same time having those fixtures. You don't have to duplicate a lot of fixtures just for a single argument. And you write them like this. So order fixture, it's a class, it has a client, so this is the dependency injection by PyTest, and then this is the actual fixture factory that is getting called. It's that simple. But it doesn't mean that you have to use it everywhere. You only use it if you have a lot of tests which are using the same, almost the same fixture, but need a little bit different arguments in them, a little bit different data. So I advise you not to use it everywhere, but in those cases, it makes a lot of sense. Now, the final thing is, if you write your tests, and if you write your code, and you are calculating the coverage over your code, but not over your tests, if you're omitting your tests, then you will see a lot of such things in your tests. I've seen code bases where there are dozens of such dead fixtures. It is not used. It is not covered. But nobody knows, because we don't see it in coverage, because many people omit your tests, the tests themselves, from the coverage information, which doesn't make sense. Because everything in your test directory should be tested, should be covered by the tests, logical. If it's not, then it means you probably should delete it. So cover your tests, and don't cover, just include the coverage for your tests, and if something in the test is not covered, well, remove it. That's it.
Okay, so thank you very much, Stanislav. Very interesting talk. So we have a couple of questions, but if you have more, feel free to raise your hand and I will bring the microphone to you. So the first question from Leandro is, if you're continuing adding exclusions for code coverage for files, deciding to move fast, at some point you might accumulate some technical debt. And so how do you balance that?
I don't add them because I want to move fast. I add them because I don't care about a piece of code. For example, there are pieces of code that do not constitute my public interface or that I don't expect to break. If I cover them and they start changing and they change with every release, then I will have to rewrite this test every single release. I don't want to do that. So it's not about moving fast and not covering something because, oh, we need to run. It's about deciding that this thing is not worth covering almost ever. Having 100% coverage and covering everything is not a silver bullet and is not necessarily good, because not everything in your code affects your public interface, and not everything in your code is stable enough to be covered.
Cool, thank you very much. So the second question is, what is your take on property-based testing?
Are we talking about hypothesis, or it depends. I think that many approaches to testing are nice. Hypothesis is really nice if that's what we're talking about. If who asked this question? If you are here, could you clarify? Hypothesis. Okay. It's nice, and it allows you to test a lot of types of things. So it allows you to test the entire type space. The problem with that is I barely ever had the need to. Almost always, my inputs were so simple and so easily just covered by Pydantic validation that I didn't need to spend time on it. Because if I tell Pydantic, okay, the minimum number of items in that list is 1, the maximum number of items in that list is 10. Well, I don't need to test it against like the 0 list, the 11 list. I know that Pydantic already has my back. So not always necessary, but a nice tool for very narrow kind of uses.
Perfect, thank you. So we have one last question before the break. So to avoid falling on the anti-pattern 1, do you think it makes sense to test the public interface first, check for the coverage of what you have been testing, and if something critical has been missing, then to test it directly?
Yeah, sometimes it makes sense. I would advise you, if possible, to also test that through the public interface. But if you consider some piece of your code critical and you cannot test it through the public interface, it's okay. it's okay to import it directly and to test it. And even the import linter has exclusions for that. Like you can put exceptions for that. Because as I said, it's an art, not a science, and one test of 1,000 might be like this. But it needs to be one of 1,000. If 30% of your tests are importing your internal logic, then it's probably not an exception. You're just probably not designing your tests well enough.
Makes sense. So thank you very much. Let's give another round of applause to Stanislav.